Hello and welcome to SkyTour LiveStream. This is Mark D'Antonio, and tonight I have a special guest with us, Carol Carl, who's also a KGRA host on KGRAradio.com, the best radio station on the planet. And as always, we have Daryl Mason, astronomer about town, with us as well. And tonight promises to be a lot of fun as we zip through the cosmos. And right now on the screen we have Saturn. I just took this picture. It's kind of low in the sky right now, but it looks pretty cool. I want to welcome Got Pyro, a new SkyTour LiveStream member, and Lionel Lorca. Welcome, and thank you for coming along on this. Tim F., as always, great to see you. And Maddie is here along with Charles Smar so far. It promises to be a good evening. We have a very, very good sky tonight. And we should have good skies till about midnight, but I don't know that we're going to go that long. We'll try. We'll see how it goes, if my voice lasts. So, first off, I just want to say hello to Daryl. How the heck are you, man?
I'm good, Mark. How are you? It's been a little while.
I know. It's been tough, but I finally got it. I've been working on the automation code and stuff for the Observatory platform once it makes it out to Arizona. And I actually revisited the roll-off roof observatory design today. I actually went to the place that has the actual building that I'm going to convert to a roll-off roof, and it looks like it's going to work really good. I consulted with a carpenter while I was there and got some really good ideas for how to make this all work. Really neat. I also want to welcome Carol Carl to the SkyTour livestream. Hello, Carol. Thank you for joining us.
Well, thank you for having me. And Daryl, we said hello earlier. Yeah, this is like quite an unexpected honor. This is definitely an honor. As we ascend into the look at this, I'm looking at Saturn. That's amazing. Yeah. I want to ask you about the roll-off aspect. Is that
sure.
how break it down for this non-scientist, non-engineer. The visual, hello, Charles Smar, I am reading this chat, and yeah, indeed, okay, lots of names, etc., familiar. Back to the roll-off quality, okay? How does that, is that, for instance, like the old-fashioned wooden, lateral pieces of, is that like a roll-top desk? How does that?
No, but
how does that work?
Okay,
okay, good.
Good question, because I actually haven't said anything about the nature. Really, think about it this way. You have a regular shed with an ordinary peaked roof, Just imagine if that roof can be cut, right, horizontally along the whole side of this building and put on rails. And then imagine those rails are attached to the roof, and the roof has its own set of rails with wheels, and you can push the roof right off the observatory, opening up the entire inside to the sky. Now,
wow.
How would you do that remotely? Well, you do that with a garage door opener.
Yeah, okay.
And a garage door opener is meant to lift a heavy door vertically. This just has to move something horizontally, so the load on this roof will be much less than if it was a regular garage door. So the garage door opener would probably last far longer in this situation than it would for a real garage door. And they last forever. See what I mean?
Yeah, not a lot of moving parts, right?
No, there's not a lot of moving parts. There's just a single garage door opener, which is tried and true and tested.
I'm sorry, one great big moving part, the roof.
Yeah, right. Exactly. Yes.
My neighbor across the street built a roll-off roof observatory a long time ago. We're talking 15, going on 20 years ago, maybe. He had a telescope very similar to yours, Mark. He had a 10-inch Meade,
wow.
And I don't know where he got the plans or if he just came up with it himself. He wasn't an engineer by training, and it worked great.
Yeah.
Make it bigger than you think you need it, because you will run out of room inside.
Yeah, this is going to be 10 by 10 in size, 10 feet by 10 feet. Way bigger than I think I need, so therefore it'll be just right.
Yeah, exactly.
Cool.
Yeah. And it's also big enough to put a second pier in there, by the way, because I am planning on having another pier in there for a second telescope. And the second telescope will be a rental pier that a university or other people can log into, subscribe to, and make use of. So that means I have to up the automation capability so that if they forget to close the roof, for instance, and it's going to rain, not that that's a big problem in Arizona, but there might be, it may dust storm, okay?
Yeah.
Because I've landed in a plane that was in a dust storm, and as we landed, they shut off the engines and they towed us to the gate because the other engines otherwise would have been sandblasted.
Yeah.
Yeah. So really cool. I want to say hi to James Dugan, who just got here, and got Pyro as a question, I think. And you said you had a question. Hey, Justin. So if you do have a question, go ahead and type it right into the chat, and Daryl or I will see it. I won't ask Carol to be looking at the chat on our behalf. She's a guest.
I could listen. I could transfer the words without perhaps the true meaning of those words, but yeah. So if necessary, I would be glad to jump in there and do that.
I appreciate it, but you don't have to. You're our guest tonight, and I thought it'd be nice.
I'm going to sit back. No, I'm going to lean in, actually. And can one lean in and put one's feet up simultaneously? Well, I'll
think
figure
so.
it out.
I think so.
Okay. We shall see.
So, for those who haven't been here before, this is our main screen. This is the telescope control section here. This is me down here. Hello, it's live, yes.
Hello.
This is me in the warm room of the observatory in the dead of winter. I really appreciate it. And then this is the view, and we can do several ways to view this. We can actually look at it this way, so we can actually see what the camera settings are. I can show you the camera settings. All right. I tend to show you this so you see more of everything. However, if you want to see what we're going to look at in the sky, then I have another view that's called our Planetarium View, and that's this one. This is tied directly to the telescope. If you notice, okay, we are on Saturn right now, and if you notice, it says scope. That's telling us right where the telescope's pointing. All right, and I can go, this red square corresponds to the field of our telescope. All right, and so you see Saturn in there like that, okay? And that's what we see in our regular view. When we come back to this view, all right, that's what we see. All right, so there's Saturn, and then there's a little star down here that's just out of the view. But you get it, and that's what we do. So we have a way of looking at our sky in both artificial ways and realistic ways. Now, because we're going to be using a roll-off roof observatory when we move to Arizona with this, we have not motorized the dome here. And it's truly a dome that rotates and the shutter opens and closes. However, what we're using here is just the good old-fashioned hand power. When I need to move the dome, I'll just go out and do it. It's 60 feet out into the front yard of my house. When we have the roll-off roof, we won't need to worry about doing anything but moving the roof off the building, and that's it. The telescope will be free and clear of the sky, for the sky, at all times at that point. So that's going to be good for us. All right. Now, if we want to know what's in the sky, we can see a variety of things in the sky right now. Right now we have Saturn right here that we're near. But that's not that far from the Omega Nebula, which is a summertime object, and it's kind of low in the sky right now. But let's go see if we can actually get to the Omega Nebula right now. All right, and we're going to zip on over. And how do I know we're zipping? Because when I go here, we will actually see the screen move here in just a moment. So, and we come here, and now if we just move us over, let me do it this way. Oh, I know why we're not going. I have to do another thing. There we go. Yeah, my after all that, my I had a issue here with the telescope. Let me make sure I'm still connected. I'm still connected. Okay, see that right there? We're moving. Yeah. Okay. Okay, so now we come back here and we grab this, and now we should be able to move ourselves over there. And here we go. So now we are moving, and the telescope is slipping on over. And if the dome isn't in the way, we should be able to have a clearer view of the Omega Nebula. Right now it just looks black, And it could be for a variety of reasons, but we can look at the view from inside the dome. Here's the telescope that you can see right there. And it seems to be facing into a somewhat clear area. We probably have a clear shot at it right now, but I'll try it out. We're not going to see it at these exposure settings, that's for sure. So let's increase the exposure settings, and I'll show you those exposure settings. Here they are. We're going to go up to a sensitivity on the camera, which goes from 50 to 409,000 in its speed, basically. We're going to go to 8,000, and instead of a 350th of a second, we're going to go do longer exposures, as you'd see that. Now the stars are coming in, okay? And we'll go, say, we'll just do a test shot of 10 seconds. Or better yet, I'll go to our 4K video mode. All right, and then when I go to 4K video mode, all I have to do is pump up the ISO here, the sensitivity. And right there in the center, you can just barely see this little fuzzy cloud, and that is the Omega Nebula. All right, and I'm going to drop us down now back to a reasonable 8,000 ISO or sensitivity. And I'm going to stop the 4K video acquisition. And now we're going to do 10 seconds at 4K. I'm sorry, at 8,000 ISO. So now we're taking a picture. And what happens is, after the picture gets taken, for those of you who haven't been here before, it automatically throws us into the view image program, which will come up right after this. There it is. And boom, there is the Omega Nebula as taken right now. Now, this is quite nice for something that's low to the horizon, don't you think, Daryl?
Yeah, it is. Some people see that as a check mark. It's upside down. And some people, it's also called the Swan Nebula. You may see the swan sitting upside down with its head to the bottom right. You might also see it as like a duck decoy lying on its back.
Yeah.
Can you see that?
Yeah, absolutely. Here's the duck's head over here. Here's the bottom of the duck decoy. And this is the water behind it as it races away from the hunter. There's the beak. Neutrino says that nebulas are the favorite of his or her. I'm not sure if Neutrino is male or female, so forgive me for that. But I do know that nebulae are my favorites as well. But this being so low to the horizon, I'm pretty happy with how it looks because it shows us that it's going to be a good night. Here's a little image processing I throw in there. Okay, so we also have the ability to do instant image processing. And you can see this is a little bit of a what we call a gamma stretch, just to kind of show us a little bit more detail with a little darker background to kind of show the nebula structure there. Came out pretty good. I'm pretty pleased.
Yeah. Carol, do you see the duck sitting on its back?
I have seen. Actually, it's like, okay, who's messing with my swimming pool, Swan? Okay, get out of there. Okay, flip it on over, folks, back the other way. No, that's amazing. It's breathtaking. It truly is.
Yeah.
Really, yeah.
It is beautiful. And if you want to see it the way Daryl was talking about, then we do it this way.
Yes, right. Exactly. Well, my
There
brain
you go.
did
Is that better,
yeah.
Daryl?
Yeah, that's wonderful. But
So now you can see the duck here. And here, this is the buckshot because the hunter shot him.
No. Okay, deflated. Ooh.
Yeah.
But, yeah, quite amazing.
Yeah. So
I have to say,
Amazing.
nebulas are my favorite too.
yeah, we really love those. And I do want to take a look at the Vale Supernova Remnant tonight. And incidentally, for those just joining us, this the filter that we're using to look at the sky right now is just performing beyond expectations. It's a very special filter to help enhance the way the nebula looks. It's meant for photographic work, not so much for visual work. And this has been just astonishing. We found many, many new details in some nebulae that we'd never been able to see before. And Daryl has seen how these things how this filter has changed the views lately.
Oh yeah, it's made a world of difference than the old filter.
Yeah.
Picking up hydrogen alpha much better, and you're getting a lot better red in your exposures.
Right.
And Just makes really pretty pictures.
Yeah, and when Daryl says the hydrogen alpha, much of this gas that we see out in the universe like this, hydrogen is the most abundant element in the universe. And hydrogen is a proton with an electron in a cloud around it, basically. And sometimes that electron is bombarded by radiation from stars, like this one right here, this hot young star, can blow off a lot of ultraviolet radiation. And what happens is the hydrogen gas nearby is excited, that is to say, it absorbs that radiation. And what happens to an atom when it absorbs radiation is its electrons go into higher shells around the atom. And sometimes they actually leave the atom. They get bumped right off the atom, and it's called ionization. And then, in a spontaneous way, the electrons rejoin the atom. That's called recombination. And when that happens, the energy that they absorbed is given off. And what atoms give off when they release some of this energy back to the interstellar medium is they give off light. And because of the nature of the location within the hydrogen atom that the electron is bouncing back down into, it gives off a particular color. And that color, by and large, is what we call hydrogen alpha, or a red light. It's very red. So we see this reddish hue here. This is exactly what we're looking at here. We're looking at the recombination of electrons bouncing back into the hydrogen atoms and giving off this wondrous red light. Some of these nebulae show this better than others, and this one has some convolutions in it that are just astonishing. The Hubble Space Telescope image of the Omega Nebula is astonishing. You could just see all the detail in here, So it's great, I want to say hi, by the way, to Daisy and Zoe Amethyst, who have joined us. Thank you for coming along. It's good to see you here. They're longtime attendees of the SkyTour LiveStream, as is Charles and Justin and so many others. James Dugan from Down Under, down in Australia, is here. And he has wonderful nebulae in his skies, and we have great galaxies. And that's what he said earlier, and I agree with it. So I think that's pretty cool. So yeah, this is the Omega Nebula. I didn't know if we'd be able to see it, but we could. And I figure...
Mark, I'm sorry, a question before you leave the area? Oh, are you going farther up?
No, that's okay.
Can we go back down to about where Saturn is right now? Show the people in Stellarium, please. Before we leave the area?
Before we leave the area and move on?
Uh-huh.
Okay, I guess we can do that. First of all, let's back out. And we come to this. Do you want us to actually go back to Saturn, or do you want to just see it?
Not to see Saturn so much. Back out a little bit so we can see the teapot under Sagittarius.
Oh, okay. Let me show the constellations then. Yeah.
Yeah. If you go out and look, you have to look fairly early in the evening now.
Yeah.
But you can see the teapot in Sagittarius right there. And the star that you will see, naked eye, right under Saturn there is called Nunki or Nunkai.
Right there, yeah.
That is the top... the upper left-hand corner of the handle of the teapot. Can you see that?
There's the handle.
And that, Nunki is the most, probably the most visible star you'll see in Sagittarius by this time of night.
Mm-hmm.
And you need to look fairly early in the evening, but just to find where you're looking at, you can see the whole teapot tipping over to the right there.
Yeah, but
and the steam, the Milky Way is the steam coming up the spout of the teapot.
And now, just to be complete, Sagittarius is not a constellation of a teapot. It's actually an archer, and here he is. This is Sagittarius the Archer, and the teapot is a pattern of stars within the overall archer. And when we see a pattern of stars like that, we call that an asterism. For instance, the Big Dipper is an asterism within a bigger constellation called Ursa Major, or the Great Bear.
Exactly.
Yeah. So it's pretty cool.
But hey, the Greeks, they saw a half-man, half-horse shooting a bow and arrow, and
they did.
Nowadays we see a teapot. It's a little more prosaic, but
exactly.
Oh, the picture it paints with the Milky Way being the steam coming out of the spot, it paints a pretty picture.
It does. It
and
does.
If you're away from city lights, you can actually see that going on.
Yeah, I'm going to take us to the Eagle now because I want to try and get to it before it sets.
Very good.
Yeah.
Thank you for indulging me.
Oh, of course. You're more than welcome. All right.
But you have to pour us a cup of tea now.
Now you have to pour Carol a cup of tea, especially. Exactly.
Yeah, well, I haven't put my tea kettle on yet. You'll hear it when it goes off.
And
wonderful.
And we do. Okay, now we're moving up to the Eagle Nebula. And the Eagle Nebula is a fascinating location in the sky. We actually, hey, Papa Tom, we actually have taken some images of the Eagle that rival some of the big observatory photos. We can see details. And in fact, they don't rival the Hubble Space Telescope, of course, because the Hubble Space Telescope, by far, takes better pictures than any ground-based observatory, mine or anyone else's, okay? And the fact of the matter is, the Hubble Space Telescope is just spectacular. And what it shows us is something called the Pillars of Creation. And the Pillars of Creation are beautiful. And I'm going to do a 15-second, 12,800 ISO photo of the Pillars of Creation. And let's see if we can actually get them. I see stars, and that's good, and hopefully the dome isn't interfering. And to figure that out, we just have to bring up our... it looks like it's a little bit... Looks like we're interfering a little bit. See that? Yeah, we might have a little... might have a little red light. Yeah, I have a red light on inside the dome for this very reason. Yeah, we do. Unfortunately, we have a little bit of interference, so we can't see the Eagle Nebula. We can see a little bit of it. But, Daryl, if you want to entertain, I will go turn the dome a little bit so we can just catch these late summer objects before they disappear for the season.
Go for it.
I'll be right back. Carol, you can talk too, of course.
Well, what can I say? I was unprepared when you said Pillars of Creation. That was just sort of like, that makes me weak in the knees, shall we say. And, but I don't know how in the world, the public wasn't prepared to see those initial images. When was that, Daryl? Do we have a year, roughly?
Oh, golly. Hubble went up in 1990, if I remember right. It's been around a while, but it had the optical problems at first. Mm-hmm. The Pillars of Creation image is it's famous. It's been around quite a while now. The beauty part of this is you can actually see the very same thing in a telescope, looking at it, with your own eye. It doesn't look as great, big, and colorful and cool as the Hubble image of the Eagle Nebula or the Pillars of Creation is, but you can see it with your own eye.
Wow. What sort of is it too scientific for me to understand, and the rest of the listeners, viewers, watchers, etc., or some of them? How was that color done? But I see Mark is back.
That's okay.
It was just what would we... In 25 words or less, what was done to it that we see the interpretation of, the results of?
What's that?
That we dealt with our...
A great big telescope and color filters tuned to various elements in the nebula. Mark can talk about the Hubble palette, I'm sure.
That is the word escaping me, the palette. Yes. Okay.
Yeah.
Yeah, when they take photos, there we go. Okay, now without the dome, you can actually see, in all its glory, you can see the Pillars of Creation here. Let me see if I can pull those out. There we go. So here's the center one, here's another one, and here's the last one. These three objects were photographed by the Hubble in exquisite detail. Now, you see noise in my image here. See this little, this crinkly stuff? This is noise based on the fact that we're using a higher ISO, that is to say, higher sensitivity settings. That makes this a noisy image. And that's expected. And that's normal, but I have a way of getting rid of all that noise when we process the images. This image is of an object, by the way. All right, when we come back to Stellarium here, and we look at how close this is to the horizon, we're not very far above the horizon here. We're only like 30 degrees, 25 degrees above the horizon. This is it. So it's actually really low in the sky, and we're actually able to still see it pretty well. You know, so that's pretty good. I'm very pleased with that. Now, we're going to come back and we're going to go back to our settings here. And I'm going to, and I'll show you the settings too. We're going to go and take this to 20 seconds. All right. And we're going to go up to 25,600. So we're going up 3 stops plus 4. So 4 stops. So in other words, it's going to be brighter by far.
Okay.
So we're going to try it now. Now you hit the button. It's off and running. And then when we come back to this image, the new one will replace it when it comes in. And you'll see it visually just replace this one here in just a few minutes. You can see this dark nebula in here. You can see this is really pretty. Right, and when we should see it get replaced here momentarily. Here we come, and let's see. Okay, you see the difference?
I see the eagle.
Now,
Oh my
now you see a very big difference here, and this is where the image processing comes into play. See, we do some instant processing, and you can see the main pillar. You can see the second and the third, and you can see this dark area here. This is the Eagle Nebula. It's a stellar nursery. It's where stars are being born. It's not a place where life like us could form at the moment. The reason is because there's so many young stars in here that are shooting off this hot ultraviolet radiation that it would make it next to impossible for life like us to actually exist in this region, because it would be literally too high a radiation zone for us. Okay, so that's the Eagle Nebula region, and all young clusters like this are probably devoid of life early on. It's after they evolve and they move away from the clusters. We were born in a cluster, and we're no longer in a cluster of stars. There was a thought at one point that we were part of what's now the Big Dipper, and a bunch of those stars. And from some distance away, we would certainly look like we're in a cluster of stars of the Big Dipper, you know. But we don't know for sure. But this region here is a very, very hot and intense area. No life can exist in there right now as we know it anyway. Carbon-based compounds would be broken apart by the high-intensity ultraviolet radiation and just wouldn't be conducive to survival, you see. But there is time on its side. The universe is a long-lived being, I guess you would call it, a long-lived entity. But there it is. There's the Eagle Nebula and all its glory, and we got to see it. So let's go back to our... any questions about that, by the way, in the chat, please go ahead and ask. I am expecting that Daryl will probably catch those if someone asks.
That was just
I'll
magnificent. Oh.
Did you like that?
I'm no Amanda,
Eagle.
but I'll try to catch it.
Okay.
Who is Amanda? Nobody, except no substitutes, right?
Yeah, there's.
Pretty much,
We're trying to
yes.
find Amanda. I let her know we were running, and it's catch as catch can, because I don't have a regular schedule for SkyTour LiveStream. My regular schedule is it's clear, let's stream.
Yeah.
So I can't blame I can't blame anyone for not being able to just drop everything, of course. So let's see. So you can see that in this area of the sky, the Sagittarius in this area, there's an awful lot here. And one of the things I'm going to do is take you up to the wild duck.
Oh.
Yeah, the wild duck. Now you say, well, wild duck, what's that? Well, you'll see. The wild duck is an interesting cluster, actually, and it's a cluster that Daryl likes too, and you'll see it now as we say to go to it. Okay.
M11 and Sputum, if I remember correctly.
You remember correctly. Okay, and we are on our way. We're heading up to it, and the first thing you'll notice is that you don't notice a thing. You'll say, well, where is it? And the thing is, the wild duck cluster is actually not as bright as you might expect. But it is a cluster of quite a number of stars. And we're going to drop our settings here. We're going to go down to just, say, 6400. And we only need about 15 seconds, if that. We could get it in 10. And we'll just take a picture of it now, and we'll see what we get. All right? I think you will like it. I know that Daryl likes it.
Oh, yeah.
Yeah.
Well, I can't imagine not liking.
Yeah, it's a dense cluster that's really quite fascinating. Daryl, while we're here, we should actually show. Carol the a globular cluster that's nearby.
Oh yeah.
Sure.
Oh. When I was a
Carol,
kid,
prime time for these objects would have been a couple, 3 months ago when they were, higher in the sky. They're getting close to setting now. As the sky wheels over the course of a year, the constellations change, and Sagittarius, Scorpius is already set from Mark's point of view.
yes.
With Jupiter, and Sagittarius is following close behind.
Yep.
And here's the Wild Duck cluster. Isn't that pretty?
Oh, that's beautiful.
Isn't that pretty? Yeah.
Ah.
Now, our filter tends to make the stars just a little blue. But it's not bad. Hello, Bobby Burgess. Thanks for coming out. Good to have you here with us. Yeah, this is beautiful. And
Doggone.
now, just imagine if this was your. What if this star right here was your home? Yeah, on this star. Now, the rest of your sky would have a lot of bright stars in it, wouldn't it? It'd be really interesting. You'd notice that you have a lot of very bright stars. Just imagine, like the star Sirius, southeast of Orion. Okay.
Yes.
That is the brightest star in the northern sky. Just imagine if you had 15 or 20. What's the plural of Sirius? Sirii. In the sky.
Yeah, think of it.
Imagine that. Maybe some of them would be bright enough that you could actually see a combined shadow from them. That's pretty interesting thought.
Star shadow.
Mm-hmm. That's right.
Think of it. Oh my
Yeah.
gosh.
And I gotta tell everybody, by the way, and I can't give any more details about this because we're under a little bit of a gag order on this, but last night I was up with Doug Trumbull in the studio, and we were being interviewed for a documentary, which we can't talk about yet. And one of the people that was there was from MIT, and he brought us debris from a crashed UFO. And the MIT metallurgical folks said that this material is not of this Earth, in summary. And that's MIT talking. So, that's a little nugget here for you guys tonight. I took pictures of all the material. I can't show it, but when I get permission to show it, I will blast it out there for all of you to see. The people doing the show, the movie, are very, very guarded about this stuff because they don't want all the wrong conclusions being drawn and supposed experts dropping out of the woodwork, that aren't experts at all. So, but it was really quite something to be holding this material. Imagine a piece of metal that is metal, okay, but it's light as a feather. That's what I experienced last night. It violates your senses. It's supposed to be heavier, you think, but it wasn't. It was extremely lightweight. And by the way, it was exceedingly strong. I was like, wow. So there's something new and really cool coming down the pike, and I will tell you more about that as I know more.
It violates your senses. That's the part that sticks with me.
Yeah.
I was going to ask. I was going for the what's the emo takeaway here? Okay,
Yeah.
and that's I think that
Yes.
yeah, we can extrapolate on that for the time being.
Yes. Yeah.
Wow.
It violates
Wow. Just
all of your
what-
senses.
Yeah.
Yep.
Oh.
And who knows? Maybe they're from a cluster like this. These are fairly young stars, but the fact is, the galaxy and the universe in general may be more than 1 billion years younger than we thought. Because we have a problem. We couldn't find the amount of mass required to make the Big Bang. And so if we don't have enough mass to make the Big Bang, well, guess what? It means that perhaps our universe is just a little spurt off a bigger bang, so to speak.
No, that's good. That's
Yeah.
good. In other words, a tree with a sucker on it, kind of. No, it doesn't
No,
work. But
but
That's a good analogy.
oh well, thank you. But yeah, What an amazing time to be on planet Earth.
Yes, absolutely so. Absolutely so. And I like being here, to be honest with you. I mean, I like not having all the answers. I don't want to live 1,000 years from now and know all the details and have to just laboriously wait for the next well-known alien contact to show up and come visit us. I'd rather be on that leading edge of trying to find them for the first time. There's never going to be another first time once we find them. There'll never be
so
an
well
exhilaration.
said. I've never thought of it in that particular sense because, yes, it doesn't matter how things change, good, bad, or indifferent. There won't be a second first contact. Wow.
That's right.
Wow. Or official. Now, what do we do about that? There are people perhaps saying, yeah, what do you mean first contact? That we left that 30 years ago.
Yeah.
So I don't know.
Yeah. I mean, there won't be any more such thing as a first contact. And that'll just be now history. First contact was on such and such a date.
Yeah.
Right?
Yeah.
And right now, we want that date. We want that to happen in the worst way.
Yeah.
I'm looking forward to it. I actually suspect that they may be here already. And I'm a science guy. I'm an astronomer, right? I got a degree in astronomy. But I didn't go down the wild and crazy far outside, of the science and start to just think that everything's an alien, okay? I never did that.
Right.
I was always one of these people that was very guarded with my opinion and still am. But I cannot anymore sit back and just watch what's happening without becoming a participant. I have to make my opinion known. Because I think that sometimes they're missing important points, Hello, Jeff Lucas. Nice to see you. Hey, Mario. Mario's here as well. Good to see you as well. Thanks for coming. Here's a globular cluster, by the way, right here.
Excellent.
Okay, this little guy is, he's almost resolved to stars. I purposely didn't resolve him all the way to stars. I wanted you to see the kind of like the snowball-y look. All right. And you'll notice this guy over here too. All right. And that's clearly something as well that we want to look at. And what we'll do is we will go to our stellar planetarium section here and zoom in. And you'll notice that right here, all right, this little green thing,
Yes.
this is an area that shows us where a star has died. And it's called the Planetary Nebula. And the Planetary Nebula is the result of a star throwing off its outer layers. And it's the last stages of a star. And when we go back to our photo that we looked at, all right, which I'll show you right now, all right, this photo right here, which shows this object right here, this guy is the remains of a dead star. And you'll see there's this little tiny whitish dot near the center of it. That's actually a white dwarf. It's the remains of the once proud and blazing star. It's all that's left. Then this gas here is a mixture of all the elements that were, some of them were synthesized in the core of the star. Some of them were in the star's atmosphere when it formed. There's a lot of oxygen here. There is hydrogen here to some extent. There's neon. There's other elements in the periodic table because stars are element factories. They make the elements that are in our periodic table. Everything you're made of was once synthesized in the fiercely hot core of a star. Isn't that just an amazing thought process?
It is something to wrap one's mind around.
It is.
Or try. And it's more than the mind. I mean, you're a science guy. What about the What about the romance with a capital R? Not the, Hallmark movies that, no, but what about that? Is that part and parcel? Is that our humanity trying to interpret?
That's the reason, by the way, that and this to you folks listening, that I wanted to have Carol on. Carol has a little bit of philosopher in her as well. And
no.
when she talks, you really have to think about what she says, because she's saying things that are actually somewhat profound many times, and I kind of appreciate her for that. And she's a good friend, and she's also an excellent host on kgraradio.com, along with yours truly on... you have the Behind the Obsidian Curtain show. What time is it on, Carol?
It is on 7 p.m. I'm just blown away by this plug and your generosity of spirit. Speaking of such. But all right, it's 7 p.m. Eastern time. That's 4 p.m. Pacific on Fridays, right before Don Ecker.
Right. Don Ecker, a good friend. I've been on his show many times. And Don is a good guy. I love how he talks. Like, hey, Mark, tell me about astronomy. And I love the way he talks. He's so wonderfully deliberate. I absolutely love his voice.
You do a good Ecker. That's very good.
I love his voice. I've heard him for years and listened to him for years.
Yeah.
Dark Matter Radio,
Yeah, very good.
And so, and of course, SkyTour Radio is our radio show. It's on Sunday nights from 8 to 10 p.m. Eastern, and that is a show that has kind of come a long way. We started out with an hour, and people demanded 2 hours. And we ended up going to 2 hours. And other hosts moved their shows around so we could have 2 hours, and I'm always indebted to my very, very good friend, Commander Cobra, for, moving his show. Because without moving...
That's pretty extraordinary. Yeah.
He has a following, and I was sort of against this from the beginning. I didn't want him to hurt his following by moving his show time, but he was okay with it. Circumstances he was dealing with too made it easier for him to change. So it kind of worked out in a sense, and I'm happy. So I just think it's great. Meanwhile, we're talking about this. We see a globular cluster where a bunch of stars formed here, and they're in this big giant ball. It's sort of like an exploding snowball of stars. And then over here, we have the very poignant death of one rather moderately sized star, kind of like our own. So if there was any beings around the star that once was, they are no more. And so that stuff kind of bothers me a lot, because we'll be there someday. That'll be us someday. There will be a planetary nebula in the heavens somewhere near Sol, which is our star. And people will say, "Oh, look at that! Maybe there was life on one of those planets," and that's true. And we're going to have to have left the planet many, many thousands, if not hundreds of thousands of years beforehand, maybe millions of years beforehand, to escape the wrath of the sun when it finally runs out of hydrogen. So that's the fate of all stars like the sun. This thing right here, this planetary nebula. Nowadays I don't do anything but just look at the beauty of these things. And we as astronomers, we try to figure out how they formed, what happened. And as astronomer, we tell you what it is. An astrophysicist tells you how it happened, and the cosmologist asks, why did it happen?
Very good. That's very good. Yeah.
And amateur astronomers tell you how pretty it is.
You know what, Daryl? That's a very, very good line. I should use that.
That's nice. That's number 4.
But you know what? That kind of belittles the amateur astronomer, and I wouldn't do that. I think that, all of us, those of us who are professional astronomers, we were amateur astronomers, just like everybody else for the longest time. And I actually had one particular person who was one of my professors, actually, when I was getting my degree, and he actually didn't know where anything was in the sky. He didn't have a clue. And I said, "You call yourself an astronomer?" And he goes, "Well, I know all about these particular B stars, these hot stars, and the ultraviolet radiation. I can give you that." And of course, he really was a very, very smart guy. I learned an awful lot from him. So, okay, Marco, hey, how you doing? I see Marco's here.
Marco.
Rockstar is here. Papa Tom. Nice to see you guys. Nice to see you guys indeed. And let me go back to our little planetarium here for a minute. I want to...
Carol, per your question a minute ago, why do we do this, or the science or the philosophy behind it? Was that sort of what you were saying?
Well, it was how. Okay, pretty obviously, just because one has the science inclination and the science baseline and the huge science education, that doesn't mean one is absent philosophical leanings, blah blah blah. And it was sort of like, what see, this is a very non-scientific question. It's not repeatable. I don't even know what the question was, but to frame it loosely, how do you when you look up and you see just that, can you just look up and see the sheer beauty?
Absolutely. Well, as I alluded to earlier, that's why I do it. It's the beauty, it's the sense of wonder of it, and the challenge at times.
And you can just automatically, and you can put away how it works, etc. The math of it. For instance, there are times when I'll see a stage production. I spend a lot of time on the legit stage, and I'll see it, and it will occur to me, I know how they did that. And so, in other words, I'm taken. My focus has shifted, and now I'm no longer, with the flow of it. But that's a reversal and a really funny. Let's kind of see if we can get the inverse of that somehow. But what I'm saying is, can you just look at the beauty and not see or think of the other times and the scientific study you did of any given portion of the sky? Yeah?
Oh,
I don't know.
I speak from an amateur astronomer's perspective, okay? Yeah, but, I mean, once you're schooled in the whys and wherefores of what's going on, it's part and parcel of it. But, hey, it's beautiful and it's wonderful, and that's why I keep doing it.
Yeah, and I don't disagree with that, actually.
I hope that answered your question.
It did. Listen, my question was all over the star map, if you will. So yes, indeed you did. Thank you very, very much. And I'll try to get more specific as time ticks forward.
Wonderful. Yeah.
Thank you.
Yeah, no, see, that's all good. I think that when you lose, if you lose your perspective on what it is you're actually looking at in the sky, if you lose the wonder and the awe factor, then it just becomes an object, and that's it. It may not carry any more meaning for you than that. For me, it has a lot of meaning, okay? When I was 9 years old, I knew I was going to be an astronomer. And it was precisely because when I went outside at night and looked up from the dark sky site where I lived and grew up, I would look up and it would take my breath away, and I'd feel homesick. And I could never explain why I felt like I belonged there rather than here. And this is actually a fundamental feeling that a lot of people have.
I want to see hands. Yeah, and I'm waving mine frantically.
Yeah.
That's very interesting. Yeah.
Yeah.
What? Yeah. I mean, you have an answer in that became your professional choice, your calling.
I did because I also knew that we weren't alone. And when I was in college, for instance, and getting my degree in astronomy after that, one of the things that I said to the director of our observatory was, this is another planetary nebula, Carol. This is called the Dumbbell Nebula. And you can
That's a planetary nebula.
Right.
God, that's gorgeous.
Yeah. And one thing I said to my director of our observatory was, I said to him, there have to be other planets like Earth out there. Why do you think so, Mr. D'Antonio? His name was Arthur. I said, Art, I can tell you why. Look at all the life forms on this planet. Beyond the multicellular organisms, when we start to get into more complex life forms, they're every last one of them, they're bilaterally symmetric. The way they interact with the world is through symmetry. Now, their internal organs, there might be one heart, okay, but it has a symmetric number of chambers. There might be, just one intestine. However, the way it's laid out, it has a symmetry all its own. All right, but even so, the way they interact outwardly with the world is through a symmetric body. And I said, this is a template that's provided by the universe. It's provided by the universe. This nebula right here, this bluish teal area, this is oxygen. Okay, this reddish area is neon and hydrogen. Okay, this is the outer shell of a star. It's going out into the interstellar medium, expanding away from this very small white dwarf you see right in the middle there, that white thing. Okay, that's the exposed core of the star left behind, and it's very, very hot and causing this gas to glow. But there's more gas beyond it, perhaps, that's stopped glowing because it's beyond the reach of the star, so to speak. And this goes out into the interstellar medium, and it ends up finding its way into nebulae that make up planets and stars. And so we end up with all these elements on our own world. Somehow, this process has spawned Earth and spawned all the life forms that are here. And we are not a random chance in the universe. The life that formed here is so diverse. We have so many different millions, hundreds of millions of different species that have come about independently on this planet. And it's all based on one atom in the periodic table. And does anyone know what that atom is? I'm asking the chat. I'm asking the chat. I'm not asking Carol. I'm not asking Daryl, because Daryl knows. Okay.
Be that way.
No, it's all because
I might know, but
one atom that is in the periodic table. It's an atom that is what we call the granddaddy of all atoms. It bonds with more things than any other atom in the periodic table, and it's the fundamental atom that makes up life. And big hint, DNA. Maddie got it. Carbon it is. Number 8 in the periodic table. Okay. And it is just incredible. Jeff, nice try. The iron is actually a remnant from number 26 in the table. That's the remnant from the supernova explosions. It's the highest element that can be forged with nucleosynthesis in the heart of a star. Beyond that, there's other processes that make the rest of those elements that we see. But that's an excellent choice, and I might have at one point thought iron as well. But the carbon atom is the granddaddy. That's the one that can make hundreds and hundreds of thousands of compounds that silicon, for instance, cannot. So when people say, what about silicon-based life? Well, okay, it's a very distant second to carbon, but carbon is by far more likely the one that it's going to be. So it's probably going to be life based on carbon. And when I said this to the director of my observatory, I said, it's going to be carbon-based life. And it's probably going to be bilaterally symmetric, too, because every life form here is bilaterally symmetric through no manipulation of ours. This is the template provided by the universe. It provided carbon. It provided oxygen. And basically, it's chomps. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Chomps. Okay? And those are the fundamental elements within DNA. They make up the amino acids. The amino acids make up our DNA, our double helix. It makes up all the proteins. It makes up all the peptide chains. It makes up everything that makes up life. And this is where we come from. Therefore, I said to him, this means that life in the universe is the rule, not the exception to me. And he was like, well, very fanciful, Mr. D'Antonio, but get back in the observatory and leave Captain Kirk to us. Yeah.
You calling me a chump? You calling me a chump, buddy?
Chomps. With an N.
Chomp? You're right. No. Okay, yeah, we'll see who has that last chuckle.
Yeah, and so anyway, in the late 80s, when the first exoplanet was actually confirmed, I went back to see Art, and I leaned into his office, and I had a smile on my face, and he was on the phone. And he covered the receiver of the phone, smiled, and looked at me and said, "It's only one planet."
Knowing exactly where you were going.
Yeah.
That's great.
Yeah, he knew where I was going to go, and so that was very
Yeah.
good. And that's the kind of relationship I had with those folks. They're very friendly, very good people. So I guess my experience with folks like that was that they weren't closed-minded. They were truly sticking to their science, as they should. I was the one stepping out on a limb all the time, saying, but I think that maybe there's life here, and here's why I think this. At least I didn't say, things like, well, I can't believe we're not alone. I did say that many, many times. I still say that on occasion, but I didn't end my argument there. I said, and here's why. And that's the thing that I lecture on all over the world. I tell people everywhere. When I was in Norway, I said this. When I was in the United States, wherever I go, I said that we are not alone, but let me give you some science to back that up. And then you can use that when people say, well, why do you believe that? You can believe it because, and I give them a whole bunch of things. For instance, the number of exoplanets that might be like the Earth, the ubiquitous nature of carbon in the universe, and how carbon was delivered to this planet, as was water. Everywhere we look, we see the building blocks of life in our own solar system. Therefore, it's going to be in other solar systems as well. Maybe not in the same abundances. There might be solar systems that have even more than we have.
Uh-huh.
Okay? And there might be some that have less. The universe is far from homogeneous. I mean, it actually had some differences, some changes. There were areas, I'm sure, that had a dearth of materials. For instance, in the globular cluster we saw earlier, there's a lot of hydrogen in those stars. What you don't see are any of the other elements. There's helium, of course, but you don't see a lot of fluorine and neon and magnesium and calcium. You don't see these guys. And those stars are poor in those other elements. They're mostly clean hydrogen type stars. They have some hydrogen and helium, because helium is the byproduct of the hydrogen fusion to make helium. And we don't see much more than that. And that's because these stars are what are called population 2 stars. They're very old. And they were formed at a time when the universe didn't have a lot of variety in the element arena. You see. And Daryl knows all this too. We've talked about it many times.
Sorry, I was muted. Oh, yeah. Many times.
Yeah. And so if one of those stars were to go and have a planetary nebula like this, we might not see a whole lot of the oxygen in the planetary nebula when the stars finally do die. We might see a different looking planetary nebula in a globular cluster. But the oldest stars in the universe so far seem to be those in the globular clusters, and there's a few others that are older. Pretty cool. Hey, Carolina.
Astonishingly cool. Hotly cool.
I gotta say hi to Carolina Sky and Zark212. How you guys doing? Thank you so much for coming out to check it out. Isn't this great, Carolina Sky? The dumbbell's beautiful tonight, and I just have to say, I'm astonished. You can see all this modeling here in the dumbbell, and I actually a little processing here to kind of show a little more detail. I have several algorithms that I've applied instantly here, and I have them kind of waiting in the background to apply. So here is without, and here is with, and you can see a little bit more detail showing up when we do that. It's pretty cool. Really neat stuff, really neat stuff. And we could go to the dumbbell, so now we're in the dumbbell, see? And of course you see the noise. But there's that central star. That central star is a white dwarf inside the dumbbell. All that's left of a once massive star. Most of the mass of the star, or a good deal of the mass of the star, ejected as this cloud around it. We know, because this is a white dwarf, we know how massive it is. It's less than 1.44 times the mass of the sun. Because if it was heavier than that, then this would be a neutron star. And if it was even heavier than a neutron star, it would be a black hole. Mm-hmm. And so we understand how some of these things happen. But our science isn't perfect. I did a lecture this Sunday for a conference here in the state, actually. And I talked about the problems with our science, where our science falls down. And the lecture is called Entering the New Science. And it talks about how in astronomy there's a number of things that we've found that just don't make any sense. We've actually had to invent things to fudge results. For instance, when you look at the galaxy, we know that the stars all orbit the galaxy. We've gone around our galaxy about 19 and a half times so far. And in that 19 and a half times, in orbiting our galaxy, we orbit it at a certain speed. Now, in our solar system, the center of mass in our solar system is the sun. Mercury speeds around the sun so that it maintains an orbit. If it went any slower, it'd fall into the sun. If it went any faster, it'd move away from the sun. So it's stabilized over time, and it goes around the sun in about 88 days. It's really close. Pluto, on the other hand, is the farthest from the sun, if you want to talk about planets. And yes, I think Pluto's a planet. That's right, I said it.
Yay!
And Pluto takes over 270 years to go around the sun. So things farther away from the gravitational center move slowly because they don't have to expend as much energy to stay in orbit. That said, when we look at galaxies, we figured, okay, stars near the center are going to orbit around the center faster. Stars on the outside are going to orbit slower. And we just said, well, that's how it works. It's got to work that way because that's how we feel. Because we've observed that here in our solar system and in other multi-body systems. Well, that's not how it works. When we looked at a galaxy, we saw that not only does the speed not decrease as you get farther away from the center, like Pluto going slower around the sun than Mercury, sometimes it actually speeds up and things farther out go faster. In fact, the galaxy spins as if it's a rigid disk. And that is it's a violation of what we call Newtonian kinematics, Newtonian physics, actually. And that's something that we didn't know how to explain. So they theorized that the only thing that could make that happen is something called dark matter. Dark matter around the outside of the galaxy in a halo, and it's called dark matter because we don't know what it is and not because it's black. Dark matter is mass that we haven't detected yet that's got gravity of its own, and so it's actually tugging and pulling along the stars and making the galaxy spin like a rigid disk. So that's the theory. And then we noticed that when we were checking something called the Hubble Constant, we were trying to figure out, when, like in 1929, when Edwin Hubble, a famous astronomer, calculated, he noticed actually that all galaxies and objects out in space at large distances from us, they're all moving away, not only from us, but from each other. And to show that for my conference talk, I actually took a surgical glove and I put a whole bunch of dots very closely spaced on it. And then I blew up the glove, and every dot on the glove moved away from every other dot on the glove. No dots approached any other dot. They were all moving farther away, and that illustrates what we noticed. And that speed at which the universe was expanding, a finding that was also one of Hubble's, was something called the Hubble Constant. And he had a certain value for it. Well, thanks to a telescope called the Planck telescope, we looked at this problem again and discovered, the Hubble Constant is no longer correct. In fact, the Hubble Constant has changed dramatically, and in fact, it looks like it's changing all the time. Wait, what's that mean? It means that the universe is not just expanding. This expansion is accelerating. So it's like you have to blow up the balloon to show these dots moving apart from each other ever faster every moment. If you're blowing it up with just like a liter of air per second, the next second you got to be blowing up with 2 liters of air per second and 3. And you've actually got to, accelerate your expansion. And that prompted another finding. And that finding was that there has to be some kind of energy out there that is a repulsive type force that's pushing everything away from each other. And the only thing that matched was a theory called dark energy. And so dark energy and dark matter became entrenched in our astronomy. And dark energy makes up 73% of the universe. Dark matter makes up 23%. Well, that's 96%, isn't it? So at 96%, that only leaves 4% of the universe that's known to us. And within that 4%, just out of curiosity, of that 4%, 2% is still missing. We can't find it. It's not enough to have made a Big Bang. So now we don't know what to do. We actually don't know the true nature of the universe at all, do we? And I open it up to you guys because I talked for a while. And by the way, hello, Laura Newbert. Good to see you here. And on to you, Carol and Daryl.
Oh, Daryl, take it, because I'm still sort of formulating anything that could possibly have any bearing here, legitimately. So I bow to you, Daryl.
He's got some interesting thoughts on this stuff.
Yeah, okay.
Oh, golly. Paint me into a corner, huh?
Okay.
Mark and I have had this discussion before. I gave up on cosmology a long time ago.
Mm-hmm.
Its recent theories are not intuitive, and frankly, I don't believe them. I think it's a failure of understanding on our part somehow. And that's pretty much it for me. Go ahead, Carol. Excuse me just a second. I'll be right back. I'll be right back.
Yeah. Hand me that paintbrush. Yeah, okay. It's sort of, well, but it's a nice palette. Okay.
Yeah.
It's a good corner. What if it's not a corner? What if it's just sort of a nice little contour? There we go. I just it's something. Now, what was the question again? No, but seriously, when one starts to think outside the box,
yes,
right, and yet, you know, who said that thing? Keep an open mind, but not so open that your brains fall out. Who was that?
Well, I've said it often, but I don't think it was me.
So we'll just make it you, just for the cause of argument. Just in general, this is all reaching me at a time when I so wish I had a better baseline scientific, education. And listen, well, what time is it now? That can be had pretty sensibly. And I can actually I can drop in here and say, listen, I read blah blah blah. Does this track? Is this at all legitimate? Yeah, right. With you guys, so that's nice. But I did get off on this tangent. What was the thread of it?
Don't worry, we're patient.
You are patient. Well, that's good, and I'm hearing lovely.
It took us tens of thousands of years to figure out what we do know about the universe. It's okay to spend 15 seconds more waiting for you to formulate a thought on it. I mean, it's really not a problem. It's really perplexing to a great many people.
Yeah, it is. And I think it's, something just you think you know a universe, okay?
Yes.
It's like thinking one has a handle on a particular trope, a meme, something that something you've been tracking innately for a long time, and you think you're savvy to it, and then boom, it's like, well, now looky here. I remember reading in the Los Angeles Times their take, complete with the illustration, which was, now mind you, this is the science department, the science bureau of the Los Angeles Times, which is a giggle, I guess, in scientific circles. But it was a string theory, and they showed 11 dimensions was what they were showing at that point.
That's right, and that's actually within string theory. That's actually reasonable.
Okay.
Okay.
So
at 12 dimensions, the universe of 12 dimensions becomes unstable. So, 10 dimensions, 11 dimensions, that works.
Okay. So 12 is that you don't want to go more spinal tap, like 11. Okay,
exactly.
Keep it at 11.
That's
right.
right.
Okay. All right. Yeah. And once again, it's there was a question here, a legitimate one. And it's fled from my brain. So it was very lonely and empty in there. So I don't remember what you pitched a question, Mark, and I'm gone on what it was.
That's okay.
It was something very grand and connected with the universe.
Yeah, no, it's okay because I don't remember the question I asked either.
Maybe we
I'm
just slipped
too
into
busy.
some dimension here.
Well, no, it's just that I tend to lose my focus when I see beautiful things like this. This is the Vale Supernova Remnant. It's just beautiful. It's a gossamer filaments of material that are spreading outward inexorably from the center of the massive cataclysmic explosion of a star, where all of its material was then thrust out into the cosmos upon the explosion of the star. And this particular remnant is bigger than several full moons in the sky. You know, it's really, really big in the night sky. Right now, if you look at the observatory, you can see that it's literally almost directly up overhead. The telescope's pointing straight up. You know, as the camera looks up into the dome, you can actually see how it's pointing almost straight up. It's almost right overhead. Really cool.
Are you supposed to make a wish or something? Or
well, what do you say? When you wish upon a stellar remnant? I mean, what do you say?
There we go. Just doesn't really quite have that ring to it. That was the original lyric, but
yes, exactly. Yeah, that's right.
That's very nice. Very nice.
Yeah.
Beautiful.
I heard a little trivia yesterday because Doug Trumbull worked on Close Encounters of the Third Kind, and Doug and I were being interviewed for this show that is coming out that had to do with this UFO debris that we actually got to play with yesterday, and it's the MIT validated it as not of Earth origin. MIT, and this is really, really high-end stuff finally, you know. And because Doug worked on Close Encounters, he has these presentations he does which shows you the behind the scenes. And he didn't do any of those for the producers or any of the folks that were there yesterday. But Doug and I were always doing work together, and he looks over and he says, you know, Steven, he means Spielberg because he worked with Spielberg. He says, Steven wanted to use, and he got permission to use, when the mothership left in Close Encounters, instead of that grand score, he got permission from Disney to use When You Wish Upon a Star. And they were going to use When You Wish Upon a Star as the exiting music for when the mothership left. But in the end, he said Steven chose not to use it. I don't know Steven Spielberg. You know, he does, but I don't.
I wonder what he based. Somehow I've got to find out.
But you can hear the riffs.
He based that decision on.
I don't know, but what he does is, I mean, the score that was done has some elements of When You Wish Upon a Star in it, and I listened to it and thought, oh, that sounds like When You Wish Upon a Star. And there's a reason for that. It's because it was influencing the music. Really, really cool stuff, you know.
That just knocks me out. That's so funny. I found myself singing that in the backyard 3 days ago from nowhere. Just sort of, however, perhaps not from nowhere, because, you know, the brain, it's very likely I read the title, you know, Close Encounters and blah, blah, blah. And so there we go, because that file was opened and out comes that amazing song.
That's right.
Right.
Yeah, and Doug was telling all of us at that point. I mean, I heard him say this before, but one of the things, I got a longer exposure coming in to show a little more detail of this momentarily. So,
look at that.
he said that he wanted to make sure that light was really in play. Okay, the telescope walked a little bit, so I'm going to have to take this exposure. But now, see, we've reached that magical point where the color starts to come in much more clearly. In the previous photo here, you can see that the color is still not quite as vibrant, right? And that, what you're noticing there, was little patches that get refined. That's the noise reduction algorithm that I've got running in the background. So there's noise, and then it gets removed, and look how much better it looks. It doesn't hurt the data at all. It just removes the color noise. So let's get this as a sharply focused object, and it will be beautiful, I think. So he was telling us all kinds of really cool, little anecdotal stories. Did you know? Remember in the movie 2001: A Space Odyssey, which he also worked on with Stanley Kubrick.
Right.
He was tasked with doing, of course, the visual effects, and he basically there was a scene where Heywood Floyd is riding to the moon and he's sleeping, and his pen comes out of his pocket and starts floating in the air next to his chair. And the flight attendant walks over and takes it out of the air and puts it back in his pocket, right? Remember that iconic scene?
Of course, yes.
How do you do that scene in an era when you can't remove strings that are holding things dangling in the air because you don't have the computing power, you don't even know how to do it? How do you make that scene work when you can't use computer-generated programs to make it happen because they have not been invented yet? They won't be invented for decades. So how do you do that? And that was Doug's task, and he had to figure out how to make that happen.
Really?
Oh yeah.
Oh my gosh.
And it's really interesting to hear how he did it. Daryl, you remember this? I think I told you the story, yeah?
Yeah, and I read the book, The Making of 2001, also.
Oh, yeah, well, that helps.
They stuck the pen on a piece of glass or plexiglass, I believe, and just held it up in front of the camera.
And it was a big circular panel of glass with rollers, and
wow,
they used double stick tape, and they actually had to roll the glass, and it looked like the pen was rolling, and they're shooting through the glass. It was optically clear. And when the flight attendant pulled it off, pulled the sticky tape off, it came off with the pen, okay, and it went back in Heywood Floyd's pocket, and the whole shot was done through glass.
That's what they call practical effects back before CGI.
Exactly.
That's right.
So it's no tech at all, except for the double stick tape.
Yeah.
Oh my God.
It's really amazing, and
love it.
Yeah, and there's a scene in the end of 2001: A Space Odyssey where Bowman is confronting himself in a mirror, and he's looking at himself in a mirror in this all white bathroom.
Yeah.
And he's in his spacesuit, right? The red spacesuit.
Yes.
You see Bowman from behind with the camera looking over his shoulder at himself, looking back at you.
Okay, I know where you're going with this.
Well, there was no way to comp out a camera in those days. So how did they get the shot? Daryl, don't say it. How did they get the shot? Hello, Ronald.
Not me.
Hey, Shep.
How did they get the shot? Now, I have never
camera.
read the answer to this. Okay, so what we see...
It is still your turn.
We are seeing, and I can't remember, is it a still image we see? Are we seeing...
No, it's film.
We're not... Okay, so we are not seeing like a screen grab.
No, there were no screen grabs.
Okay. Oh, God. I don't know. This means I don't get to come back next week. Is that right?
That's not true. No, you want to hear?
Cue the music.
It's really cool. It's really cool. And
okay.
In order to get the shot over the shoulder, they had the camera over Bowman's shoulder, just like it looks like. So there was a camera there. But why didn't you see it in the mirror? The answer is because it wasn't a mirror. It was an opening into another identical set in mirror production, made in a mirror production way. And there was Bowman was actually in that suit.
Oh, God.
Bowman was in the suit on the other side of the frame, of that window frame. And
that's genius.
A different actor was looking toward the window frame because you never saw his face.
Right.
And that's Doug's illusion that he created there. So just little things like that, and he's got dozens of them.
I would just love to know what he was doing when that came to him. Yeah. What had he been like thinking about nothing but that, and then put it on the, shall we say, back burner, and then there it was, did it in a dream, or what? Yeah. Oh God.
Yeah.
Wow.
I can find out. I'll be seeing him again soon. We're supposed to go to Niagara Falls and do filming Wednesday through Friday, but I'm not sure we will because I really need my commercial drone license because we got permission to fly over Niagara Falls from the Park Service
fantastic.
and from the FAA, etc. But
Wow.
they want someone with a commercial drone license, and one of the guys on the crew actually has his license, so he'll probably fly. That'd be great. So anyway, yeah, no, I'll ask Doug that question. But
Oh, yeah. Thank
there's
you. That would be
dozens of
great.
these things, and when he does the presentation, you just find yourself going, "Wow!"
Yeah, yeah, exactly.
Yeah,
Think about
and going back to Close Encounters, you remember the scene where Roy Neary is sitting in his truck, and another truck pulls up behind him, and he leans his hand out the window and just waves him to go by.
Oh, yeah.
And the truck then just goes up. It's not a truck after
it
all.
ain't no truck. Yeah, okay.
Right. And he looks out, and he gets sunburn from this thing.
Yes.
There's some photos in Doug's presentation showing that rig that they created to make those bright lights down on the actors. And it's just really fascinating. Really
Oh,
fascinating how they did all that. Oh,
That's
and Doug's really proud of the shot. Did you know there's an insectoid in Close Encounters of the Third Kind? There's an insectoid creature. It's not a bunch of little grays and
Yeah. No, this is ringing a bell. Okay, this is something that I can't remember the details, but this is something brand new to my radar, and it didn't stick.
Yeah.
But this is something I've just heard within the last couple of. No, go ahead.
Well,
May I take a
all
shot
right.
at that?
yeah, sure, go ahead.
Okay.
I could be wrong, but during the scene where the aliens first come out the bottom of the big spaceship, you have all the little grays running around, but there's also a very tall, spindly-looking one with a very long, elongated, skinny limbs. Is that the one you're talking about, the insectoid?
That is indeed the one, Daryl. Well done.
Wow.
And
Okay.
Daryl, Doug had
Wow.
Doug made the puppet. That's actually a puppet that was operated by several people, and they worked really hard to get that scene just right. And it was actually an insectoid, and they were trying to show that the insects, the reptilian, and the grays all had a common blended heritage. Isn't that cool?
That is so cool,
Yeah.
and I can't believe that I didn't remember that when I think
that's
how many
okay.
times I've seen that film. No. And I'm wondering, it's got to be. I mean, how many frames is? I mean, how many? If you count beats, blah blah blah. How long do we actually see it?
Yeah.
It's got to be more than a blink, but I don't. And now
Doug
now
said-
I can't trust my visual memory. Did I just now visualize it, and edit it back in, or do I remember having seen it?
Well,
And I can't answer.
Doug said it was in the film for 13 seconds.
13 seconds.
That's
Thank
it.
you kindly. So,
And you ready for this?
okay. Yeah, I guess.
Here's
Sure.
another good one, and Daryl, you probably know this one. And to the chat, in Close Encounters of the Third Kind, R2-D2 appeared in that film. Where was he, and when did you see him? Dun, 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 dun.
I think I might know.
Okay, then I'll let.
Okay.
I don't remember that.
Okay. Yeah. Carol, you want to go for it?
I'm gonna try. It's when Dreyfus and what's her name, and I never can remember her name. Before they look down on the entire thing, and the lights are they're sort of up in the rocks, and we see a little creature come close to them, but then go. No.
No.
All
No.
right.
And meanwhile, to those who are actually watching SkyTour LiveStream, we're
No,
actually
look at that. Really.
this is the Supernova Remnant. When you take it at a little longer exposure, you see this beautiful blue wave front here as this stuff is moving outward from the center of the explosion, ever moving, and will continue to move until it's stopped by interstellar material. It gets wavy like this along the wavefront because it's impacting areas of higher and lower density. Space isn't empty, guys. It's actually full of other gas, other dust, and it will distort an explosive blast like this. Otherwise, it'd be perfectly spherical. So, anyway, it's just beautiful, and we're getting these beautiful colors from the ionization created by stars as it's passing through here. Stunning stuff. And to answer the question, the trivia question, where was R2-D2? Tim F, good guess. He says it was a toy. Actually, believe it or not, it was on the model of the large mothership when it was coming down. There was a scene where it was passing by. You'd see it going right in front of you, rotating slowly, and there was R2-D2.
Oh.
And right next to R2-D2 was a mailbox. Okay? And there was a World War II Japanese Zero aircraft on there, and several other little cool trinkets that the model makers put on there, just as little, what do we call, in-jokes. We've all done them. I've made in-jokes on some of the models I've made as well. Even for Doug, and on the stuff he's done. And what's Doug's response? He smiles and laughs. Oh, really? That's cool. You know?
That's great.
Yeah.
Yeah.
Yes, sir.
Yeah,
Zark.
well, as long as it doesn't, split the focus or confuse people or mislead or something. Yeah, why not?
Yeah. I mean, it's a fantasy, right? It's a movie, and so we made a movie called Ufotog, which was about a scientist who called aliens down using this special EMP device, which I built here actually in the shop. And in that movie, I don't think there's a scene in the movie that doesn't have something in it that I did. Throughout the whole movie, everywhere I look, there's something I did. And remember Hal, in 2001?
Of course, yes.
I'm sorry, Dave. I'm afraid I can't do that. Open the pod bay doors, please, Hal. I'm sorry, Dave. I can't do that. Shut up, Hal. Open the damn doors. Well, Hal 2 was created for Ufotog, and I created Hal 2. And Doug instructed me what he wanted, and I made a twin. I made a 3D Hal that had two cameras right next to each other, big lenses, beautiful illumination of inside the lens, the same way as Hal, with actually red on the top and blue on the bottom. It was really beautiful. And we called it HAL 2 during the production. It was like, okay, where's HAL 2? Oh, I was over here. Okay, we made one great hero version of HAL 2 that was functional, and it was a side-by-side 3D camera system. So really cool, and that's just a lot of fun, Okay, so now.
God, that's an amazing.
Oh, it's a lot of fun, yeah. I mean, it was a great deal of fun, and all this stuff is stuff that can be, discovered. It's not like trying to hide anything,
Right.
I don't mind. I want to hear what people think. I think a lot of people would find it fascinating to, visit the studio. And I actually tell people, if they're going to be in the Connecticut area for any period of time, I'll arrange to have you come up and check out the studio and meet Doug. He loves it. I mean, I told Doug 2 days ago, hey, this guy's coming in from Los Angeles. He's doing a documentary. He wants to interview me, but he wants to interview us. So I'd like to have him, come up to the studio. You going to be okay to do that? Sure. Well, he was late. He went to MIT ahead of time, and, he didn't get to the studio for hours beyond the time he said he was going to be here. And when he got here, we filmed, and when it took us from 7:30 in the evening until 2 in the morning to do our shooting last night.
Dedication.
And we didn't even, I mean, you almost didn't notice. Because, we were talking about a topic that was near and dear to every single person in that room. This, people recognize, this is my favorite double star of all time. It's a star called Albireo. And Albireo is a star that, if you notice, it has a blue component here and an orange component here. And the way to see that, actually, is to do something crazy. I'm actually going to turn off the tracking by going to our view here. Let's do this. And I'm going to turn off the track. Okay? So hit that button, and tracking will stop. And then that'll mean that this will start drifting. So if I put the cursor there, you can see it's drifting. You're actually watching the Earth rotating out from under the stars. Okay? And now we go back here and we'll just take a quick shot. We don't have to do 32,000. We can just bring it down. I'm at let's see, I'll show you what I'm doing. So I'm gonna take a 8,000. Nah, don't even have to do 6,400 for 10 seconds. Okay. And if you don't know the colors of the stars, then do this. You just take a short time exposure of the stars and let them drift across the view, and you'll see the colors really beautifully. It's better than just trying to see it, okay? But here you go.
Oh.
Now you can see right here, you can see that we have this orange star and a blue star and a little bit of the dome. The dome's a little bit in the way here, you know? So that's a little issue we're having right now. I have to move the dome, I guess, huh? That's what happens when you talk so much. You just lose sight of the fact that the dome is moving. But it's okay. It's all right. And
That's pretty spectacular.
I would like to show the Ring Nebula, but I don't think that... I mean, we're going to go with the Ring Nebula, but you know what? I suspect the dome is going to be in the way. Let's take a look. Okay, well, we got that. And we're going to go back to this, and like that, and like this, and bring this up now. No, wrong one. Bring this up. Okay, and now let me bring up my camera again. All right, here we are, and you can see the telescope's just a little bit peeking over the edge there. So if I went to look at the Ring Nebula, it's going to be out here somewhere, so I have to move the dome. And you notice I still have tracking off, so I'm going to go turn the tracking back on by doing this. Click. And now tracking starts, and you'll notice that the telescope is now following the stars again. You notice it's not drifting. That's what we want. So, Daryl, you can carry us for a few minutes while I go move the dome, yeah?
Sure.
All right. I'm thinking that I will, I may change gears. I may bring us to the northern sky so we can check out Cassiopeia and Andromeda and some more of those clusters, which are just beautiful.
Oh.
I'm also going to make sure that our sky's still clear because we have issues with clouds later on than we hear. But I shall be back in just a few minutes, and I trust that all of you will be in good shape with Daryl and Carol and their friend Will Farrell and Meryl.
Yeah.
Meryl, Carol, Daryl, and Farrell.
Yeah. Yep. Like the old Bob Newhart show.
That's right. This is my brother Daryl, my other brother Daryl, and
Yeah.
Please.
And Larry, I think there's.
Larry. Okay, yeah.
Yeah. Okay.
I know Daryl's heard it all
Please.
though. Yeah, he's like, yeah, okay, I've heard this before.
I've heard that about 10,000 times.
Listen. I couldn't come up with anything fresh for you. I didn't.
Do we get anything for the
That's fine.
for the 10,000th? That's actually that's record breaking. That's good.
Right, we need an orchestra hit here on some keyboard.
That's right.
Okay. Yeah. Okay. But
That's funny.
mine's in the other room, so okay. Yeah.
Okay, well, I'm going to be right back, guys. I'm just going to go and move the dome, bring us over to the northern sky. We see Alberio here, and now we'll leave summer behind and head into the winter sky. I shall return.
We're not going to do the Ring Neb.
He's going to do something. He's going to move something.
Yeah,
so it's in order to do that. I think that's where he was going. Right. He would know better than I.
Where he's on Alberio there,
Yes.
not a long jump to what's called the Ring Nebula, which is a really pretty, it's called Messier 57 up in the constellation Lyra. Looks like a big smoke ring floating out in space, and that's kind of what it is. It's another planetary nebula. I thought he said he was going to go there first, but then he said he's going to rotate the dome so he's facing the northern sky, so we can see the Cassiopeia, the stars of fall coming up, stuff like that.
Yes.
So
it's definitely
maybe we won't see
fall
tonight.
or if you said it's not a far journey, as the telescope flies.
Well, seeing how much he's turning that dome, we're going to be looking the other way, I think.
Right. Okay. See, I don't have an interpretation for that yet. Okay. Wow.
Yeah.
Mm-hmm.
But anyway, where the summer stars are falling off to the west now, and all the bright stars of summer are west of the overhead meridian by, 8:30, 9 o'clock at night now. So they're going away, and the stars of fall are coming up in the east and the northeast, and I guess that's where we're turning our focus tonight.
Yeah.
If any of you people have an interest in observational astronomy, naked eye or binoculars, an interesting thing is happening over in the west right now, right after sunset. Mercury and Venus have both returned to the evening sky. I was having no luck finding them until I finally picked up Venus. I've seen it several nights since, in just the last week or so. The plane of the ecliptic, this is the plane that all the planets in the sun and moon run in. It's lying very shallow to the western horizon right now. And I have acquired Venus. I have not been able to catch Mercury yet. That plane is so shallow to the western horizon that I'm basically having to look the instant the sun sets to see Venus at all before it sets. And Mercury should be over to its left a little bit. If you look with binoculars, make sure the sun is set, though, so you don't blind yourself. But you can catch Venus, and if you're lucky and you have a lower western horizon than me, you may catch Mercury also.
Yeah,
Venus is going to be rising for months, but Mercury is going to come and go pretty quick.
Yeah, and I missed it tonight. The sun is just setting here, but we have an amazing tree line. And so if you blink, you miss it, and that's what happens. So, but tomorrow should present pretty much the same, relatively speaking.
I'm sorry, can you rephrase that?
Oh, okay. This thing of Venus being gone very quickly, just as soon as the sun sets. Yes.
Yeah. Well, it's going to set very soon after the sun does.
Right, and that's going to continue for the time being, right?
Venus is going to continue moving away from the sun for months.
Yes, right.
And hopefully it's going to pop up higher in the sky later during this apparition. But it's basically sliding south along the western horizon right now. And Mercury is going to come and go in pretty short order because, as Mark mentioned earlier, it only takes 88 days to orbit the sun, and so it's going to come and go pretty quick.
It does. And this is the Andromeda Galaxy.
Oh.
This is a beautiful, beautiful galaxy. It's 2 million light years away. You can see the dark nebula in here, the dust, the obscuring dust that's in the disks of all the galaxies. You can see it's here. Andromeda is really quite fascinating. This view of the Andromeda Galaxy, you can't see the whole thing. It extends beyond this edge and extends far beyond this edge. So that's the Andromeda Galaxy. You can see this with your eye in a reasonably dark sky. And it's also on a collision course for the Milky Way. It has about 1 trillion stars possibly, so it's a lot larger than our galaxy, which might have, maybe anywhere from 150 billion stars to as high as 400 billion stars. But this, we have over 1 trillion stars in this galaxy. So it's sort of like the dominant neighborhood galaxy. It's the bully of the block, So that said, it's beautiful. And I took a fairly long exposure of it. Let me come back and we actually did 12,800 for 15 seconds. I'm going to go up by 2 stops. Make that 3. So 3 stops. So we get even more detail, and we'll stay at 15 seconds. Let's take a photo and see what we get now. And as you can see, the telescope is actually, let me move this over a little bit. You can see the telescope is aiming out the dome that way. There we go. Okay, our photo was done. I can bring us back in. Where are we going? Okay, and you can see there's a little more detail here. We also had a little bit of walking. I call it walking. You can see the stars are slightly elongated. But we also have noise, and that happens whenever you increase the sensitivity or the ISO, you get this noise. I remove that noise, and you get these beautiful images. But I should do classes on that, you know. Show people how to do that.
It's a dramatic difference.
Yeah.
Yeah.
Jeff, you're right. ISO 3200 at 46 seconds. That's true. I can actually, do the thing. Basically, this program allows me to handle my camera like any remote, so I could take arbitrarily long exposures if I want to. But we tend to keep things at 30 seconds max here, because this keeps the wait time down for everybody. But so if I wanted to do it, I get a slightly lower exposure. I could go to 6400 and do the same type of thing. I think you might have seen the exposure, Jeff, that we did when I used the 5-inch rich field refractor that's on the telescope. Currently not using that. Now we're using the main scope. And we took a picture of the Andromeda Galaxy. You saw the beautiful attendant galaxies along with it, 32 and 110, and then this in the galaxy, and you could actually see quite a lot. And that was a 20-second shot, and I took it, I think, at 20,000 ISO, and that is to say 20,000 sensitivity, and that was thanks, yeah, and that was pretty good considering that. I could remove the noise. Getting rid of the noise is really important. If you can get rid of the noise, then you can take a longer shot. Now, there's a limit to how much noise you can remove and before it actually degrades data. And so I run on that hairy edge all the time. But you have to. You have to in order to do this, you know. And Jeff Lucas, who's also an astrophotographer and a darn good one, knows that well. So, this is important, to try and you push your limits, right, as we all do, but we try to do it in such a way that we can actually get a reasonable result. We'll come back to the Andromeda Galaxy as the night goes on here. It gets higher in the sky, so that's not a problem. So what I'd like to do now, though, is I want to bring us down to this galaxy, if we can see it. I'm hoping that the dome isn't in the way. This is called the Triangulum Galaxy. The Triangulum Galaxy is a really interesting place because it has a lot of other objects in it that are fun to look at. Among them are these absolutely stunning other star-forming regions called H2 regions, and these H2 regions, I can see that our telescope is going to probably be hitting the edge of the dome here. We're going to be catching an edge of the dome, but I'll take a quick shot just to show you what we're looking at. And these H2 regions are beautiful because they actually are quite visible. So let's do 15 seconds at 25,600. No, 20. All right, and we'll see what we get. And that's about, I think that works for us. We will get a little bit of red because we're getting an impingement from the dome, but that's okay. We're just having fun, right?
Right.
Yeah. And my thanks to all of you that have come out here to watch tonight. We love looking at the dark sky, the deep sky. We have a really good filter that we're using. It's called an ultra high contrast filter, and it's actually an ultra high contrast S filter. And we do have the dome quite badly, as a matter of fact. But
Gee, Mal, sure it'd be great if we had some grenades, huh?
but look at, even though we have the dome, this is the spiral galaxy. What's kind of interesting is it illustrates, you can actually see these regions. Here's one of these regions right here. This is actually in one of the spiral arms of the galaxy. It's actually a gigantic association of hot young stars called an OB association, because they're O stars and B stars in the OBAFGKM stellar classification scheme. And I would not want to be anywhere near them. And you can see other of these here. If I move the dome, we'll see this far better. If you'd like me to go move the dome, I will. I didn't think I was going to be going this far down. Tell you what, I will come back to that, and I will move it. But right now, what I'd like to do is I want to bring us to another thing that is more of the primary reason that I came this way. I came all this way to show y'all something, and I'm going to do it. I'm going to be doing it here. All right, and...
Otherwise, you have to send T-shirts, so...
That is right, yeah. Okay. See, this is Perseus right here. Okay, and Perseus is right next to Cassiopeia, which is right here. This is Cassiopeia sitting here in the chair. Okay, and that's the mythology. And Cassiopeia is laden with tremendous number of objects. Among them is one that is this guy right here. A lot of fun to look at, really enjoyable to go to. And we're going to go here. This is called the double cluster. Now, the double cluster is a fascinating location in space. I'll tell you why. Because the double cluster is not just a cluster that has like just a few stars in it. It's got a huge number of stars in it. And it's a double cluster. That is a pair of clusters that look like they belong together. It's really cool and fascinating. So let's actually get this framed up. I'm going to go into a 4K mode quickly and increase. There you go. So you can see what's going on. I'm increasing now, and you can see the stars. This is a live view now, and we'll move it over. This is a live high-end view of the sky. Okay. Isn't that beautiful?
Unbelievable.
It's like using your eye to look out of the telescope. This is not a photo. This is live. You can actually see the twinkling of the stars as the light gets in the way. And if we actually zoom in a little bit on this, you can actually see the twinkling effect even more. See that? It's happening right before your eyes.
And that ain't Hollywood, no.
No, it's not. No.
Oh,
Yeah.
God.
So it's just beautiful, and so we actually, I really enjoy doing this kind of thing. Yeah.
Got a very red star right there.
Yeah, this
Lower right.
This one.
Yeah, I think that's it. Or the view you had just before this one.
Okay, well that
up
was
into the like
that was
12:30.
That's
right
when
up
when I did this. You're talking about this.
Yeah.
Yes.
Yeah.
Yeah.
That's
same star.
Yes. Yeah, and of course, this music, after having talked about Doug Trumbull, is perfect. The Blue Danube Waltz, which of course,
fantastic.
as Daryl and I have said, and Daryl said to me, all he can see when he hears this is the Pan Am Clipper rotating in the dance with the space station as it docks. And that's all I can ever see too. Yep, that's all I can see too.
Ever and ever.
Yeah.
Owns it. Yep. Yeah.
Do you know I know every bit of the song? I can hum it and with all the parts because I have gone over this so many times in my head as a kid that I know every little piece of this song. It's crazy. All right, let me turn off this video here and drop us down and take a beautiful photo, shall we? And we don't need 20 seconds. I think 10 seconds at 12,800, more than sufficient. Huh. Yeah, thank you, Shep. This is free. This is free, yes.
How delightful.
Let's bring this down now.
Thank you, Mark.
Look at that. So here we are. Here's the two. Now the camera rotates, which I don't like, but I can fix that, just like that. Okay. Isn't that beautiful? Wow. Now here's what's interesting about the double cluster.
Just spectacular.
The double cluster is interesting because the stars, although they're relatively same distance from us, one of the things about the cluster which is fascinating is that this cluster is at a very different distance than this cluster. They're actually very far from each other, yet because one's closer and one's farther away, they look like they're closer in the sky, but that's just because of an illusion. See what I mean? They're far from each other.
Absolutely. I'm trying to look at that entirely differently now. That's going to take a second. Yeah. Oh my God.
Yeah.
Say that one more time.
There's one cluster that's a little bit closer to us, and
yes.
and because of the angle which we're looking at them, they look like they're very close in the sky, and that's just the apparent separation. The actual separation is huge. You know, it's really cool.
Completely.
And we do something.
Mark.
Yeah.
I'm sorry. Continue, please.
Okay, and don't forget your thought. We use a 3D universe simulator called Space Engine, and I like to take people on journeys through the sky. And I've gone to the double cluster, and we've gone to see the double cluster, and you see how one is really far from the other. It's very, very cool, and I'll do it again. I know that there's people that love to watch the journeys because, you know, with a blue Danube in the background and zipping along. Oh, it's just really pretty. I used to do this at the studio. We have the highest end digital planetarium system called Digistar, and it was given to us by Ian Evans and Sutherland, who make it. And my task was to take people on tours of the universe, and it was always off the cuff. I didn't have a planned route. I would sometimes take them to Saturn, fly through the rings, and then go on to the Pleiades. Okay? And then we would circle the Pleiades. But I would do it all with a joystick, and I would actually change the speed at which I'm going out. And it was fun to do, and that experience led me to be able to use Space Engine that way. Now I can take people in Space Engine flying like a spaceship would fly. So, you know, you've got to slow down, you've got to turn around and slow down. You've got to do all the things that inertia and mass would force you to utilize or in order to slow down properly. So you have to start slowing down ahead of time. I mean, we can go just above craters on the moon and zip along and go down into the crater, rise up above the crater as we come out. Really cool stuff. And we'll do another one of those streams at some point. But on a night like
music
this,
too.
Always do. And by the way, when I was out there, I did see clouds approaching. Our southern horizon is no good, so that's why we're looking into the north right now, and we have more time. So I love doing this for all of you guys, and I mean beyond Carol and Daryl. I really enjoy the loyal following that we have in SkyTour LiveStream. I'm thinking of starting a Patreon with SkyTour LiveStream as well. Don't know whether that's a good idea or not. I'd like to hear about that and see if there's a reason why that might make sense for some of you. And then we'll have subscriber content and stuff like that goes above and beyond what we see here.
That's a great idea.
Yeah, I think that it might make more sense. But it's not going to change what I do. I mean, I'm still doing this. We're still going to have this. We're still going to have the blue Danube behind the double cluster.
Right.
We're still going to have all the same types of things that we do. And that's not going to change. Now, I want to go to this guy and see if we can see this. This is right nearby. This is called the Fish Head Nebula. What is that? Well, it looks like a fish head. But we're going to check it out and see if, in fact, it's visible at all. I know that when we did the wide-angle view... Hello, calculator. Go away. That's what happens when you hit the function key by accident. Okay.
Yeah.
Yeah.
Right.
Let's make sure we're covered here. Oh, yeah, telescope is good. If you look at the telescope here, okay, you can see this is the back end of the camera there. This is the body of the telescope. It's facing straight out the dome. This is one of the big yoke mounts on the telescope, on the big forks. So we're doing okay. We are in good shape. And let's bring up this, and I do a little jog. I've noticed that I need to do a little bit of a jog to keep my object properly oriented. So we're gonna do 15 seconds at 16,000. We'll try that. See what we get. We want to see the Fish Head Nebula, which is going to be, should be, right about here.
Okay.
And it's going to be somewhat faint, but this is a test. This is only a test. Do not attempt to adjust your television. Yes.
Fish Head is part of the Heart Nebula, is it not?
Yes, it is. And there it is. Look at that. Yeah.
Oh my.
And I'm going to rotate it again so that it goes where I said it would go.
Yeah.
Wow, look at that. So there it is. And as a first shot, I can tell you this. If I was to actually play with this some more, I can actually get it looking really, really good. I really could. And yes, this is a magnified view, actually. Wow, that's something. Not bad, not bad. So the fish head is kind of interesting. It's faint, like I said, but I can probably tease a little more information out of it. And let's go and do that, shall we? I'm going to go and let me go into my viewer here. And let's play with some of the features here. Okay, so let us bring up some of that. Does this help us at all? I don't
know, but it's great to see the process.
Oh.
It's fascinating.
Yeah, I see what's going on. I gotta do this. Okay, and then I have to do that. I have to do this. Okay, now we can do it. Oh, yeah, this is a good song, too.
Oh, yeah.
This is Gymnopedia, is that what it is?
Yes. Can't think of the composer at the moment. Damn. French, I think.
Yeah. It's number 2.
Debussy?
No, it's some guy who's a little more modern. He was sort of coming along just before things got atonal musically, like Schoenberg in Germany and Albanberg. I can't think of it. Darn it.
As you can see, this is Carol's expertise when it comes to music. She is all over that. Look at that beautiful nebula.
Well, I mean, I try. If I was really over it, all over it, I would. Maybe I am all over it. No, but it's. I can't think of the guy's name.
I just have to say goodnight to Carolina Sky. Thank you so much for coming out and hanging out with us and talking to us. You guys, you have a good night, Carolina. And we will see you soon.
Hope the skies are fair in Carolina.
Yeah. This is beautiful. Really, really pretty. Yeah, okay, so let's move on. Let's move on. And while we're here, why don't we go down to the heart of the nebula? It's the heart of the heart. And let us move there. It's not a big move. It's right next door. And here we go. And the telescope will barely even look like it's moved. All right. And we're fine. It's looking straight out. And now we can look at the heart of the heart. That cluster is an important piece. Okay. 15 at 16,000. Let's do it.
Wow.
And see what we get. Carol, thank you for joining us. I hope that we're not keeping you from things that you need to do tonight, but it's very nice of you to join us. You were gracious with me when I was on your show.
Oh, well, you were a great guest, and thank you for having me on this show. This is remarkable. And, oh, by the way, that was Eric Satie.
Oh, okay.
That we were listening to.
Very good, thank you.
Satie. I had to look it up. Yeah. Wow.
Yeah, this is
just a huge wow factor for me. I'm sorry.
See
Look
that
at that.
nebula? And if we do a little processing, I can affect that a little better. And let's go into our colors here and play with this just a little bit. Maybe like that. There we go. So you actually see a little more of this convolution here. This is a really interesting location in interstellar space. Cassiopeia is one of these places that actually has a whole lot of nebulae in it, and it's hard to miss them, but easy to miss them when all you do is look up in the night sky. When you have a light polluted sky, you don't see any of these nebula. You just see, this. This is about all you see, right? You just see stars.
Right.
You don't see big names in them either, So yeah, and it's just beautiful. And now I want to take you to some of the other little gems that are here. Well, one of them is called the Fuzzy Butterfly Cluster. Okay. Now, we know it as NGC 654. That's New General Catalog number 654. And, however, it's also, NGC 654 is also the Fuzzy Butterfly. Sounds like a drink. I want a fuzzy butterfly, Bart. Okay.
Does that come with an umbrella or just little wings? Yeah.
I don't know. It comes with like a little butterfly, right?
Oh, a real one. No, on a toothpick, please. That's
Oh, come on. That's
beyond
insect,
Blade Runner.
Insect collection stuff. Yeah.
Yeah. Okay. Yeah.
That's funny.
Oh.
Yeah. So here we go. So now,
Yes.
we're back here, and there we got our controls up. And now let me just bring us. I think we want to go here. But I'm going to just trust that it'll be around. So I'm going to go, we'll just say 15 seconds at 16,000 here to catch the fuzzy butterfly. And it's funny because the planetarium program we're using has some of these names in there that some of them are accepted names. And, some are kind of nicknames.
Yeah.
Now, the fuzzy butterfly was not those stars we saw up there, by the way. Okay? The fuzzy butterfly is actually down here. This is the fuzzy butterfly. This faint cluster. And so that is the fuzzy butterfly. Now, it's hard to discern. It's hard to make out the difference. But it's really cool when you look at these things and you figure them out. It actually comes back to being, just experienced with it and playing with it a lot, doing these things a lot.
I actually think I can see the butterfly, but that couldn't be. That would be too easy.
Yes, it probably would be, because I don't know if it's actually a butterfly at all, or if it even looks like a butterfly.
Well, see, my brain is doing that. I only wish I could control that. Yeah, see, I see two wings, and then I see a vertical, sort of slightly on the diagonal thing. Okay, that's a wing right there, what you're doing. And then if you go down toward like 6 o'clock, that's the bottom of the wing. 6 o'clock on a... Well, see, we're dealing with diagonal. But then the body.
Yeah, right?
The body would be to your right.
Yeah.
Okay.
Yeah.
And straight up, and then another wing. I don't know. I do not know. Sort of, I guess, my brain's doing this connect the dots kind of thing.
Yeah, that's what the brains do. That's how you get bunnies out of clouds. It's pareidolia.
Yeah, right.
There's nothing wrong with it. That serves us well. That recognition thing is something kind of unique to us. I want to say hi to Deborah Hearn. She said hi a few minutes ago, and I typed hello to her, but I'll just say hi. Yeah. And Shep says, I can see the fuzzy. Yeah, Shep, that's good. Being able to see the fuzzy is the first step in becoming a fuzzy spotter like us.
Yay!
Well done. Well done. That's what I love about this. Everybody has their own fun and revelations. I actually have a lot of fun with it with people who come to see this. All right, let me come back in here now.
You're just doing an incredible thing for everybody. It's amazing.
It's fun. It's fun, And Daryl, did you go through the night sky things yet?
No, well, just a little bit while you were out turning the dome. I talked about Venus and Mercury over in the west just after sunset, in the west-southwest after sunset.
Okay.
And I talked about the bright stars this summer all moving into the western half of the sky. So I guess I did, yeah.
Okay. I know that we didn't have a show last night, folks, and that's because our producer needed to rest. He actually ended up in the hospital because he works too hard. He works too darn hard, and
he does.
And he ends up running himself down. So we basically said, I made the call actually yesterday. I said to him, I'm telling you that we're not doing a show tonight because you need the rest. And you know what? He didn't argue with me. Didn't argue with me. So we will return next week at 8 p.m. Sunday night. Now, I do have to go to Arizona from the 7th to the 18th of November. And some of you know this. I'm going to teach the Mutual UFO Network Boot Camp. One of the teachers of a special group of people that really know their stuff. And then after that, that's just 2 days. And then after that, I'll be in the desert most of the rest of the time doing the site planning for the new observatory. Because I wasn't kidding when I said I was moving this all to Arizona under dark skies. I can taste it. And I cannot wait to get this dark sky and show it to you. Oh, you guys have no idea. I've never had a big instrument like this under a dark sky. So this is going to be just excellence beyond compare, I can tell you that. I don't think I'll sleep, frankly. I don't think so. And
pace yourself. Sleep when it's light.
I don't know.
That doesn't matter, does it?
I could do that, actually. That's a great idea.
Well.
But you got to hear something, too. There's a problem. Arizona is sometimes 3 hours behind Connecticut, sometimes 2. So if I'm going to do these streams when it's dark in Arizona, then they're going to be a little later here. So we would end up doing streams around 10 p.m. And it would still be 7 p.m. sometimes where it's not quite dark out there. So we're going to have to go later. We're going to have to start later. Now the alternative is I put one out in Norway, and then we can do our streams at like 2 in the afternoon, and then it'll be 8 o'clock in Norway,
Right. I figure it.
Yeah, except that Norway doesn't have clear skies many times,
Right.
And of course, my dear friend Ket Thorvaldsen lives in Norway, and she's the other half of the new science tour that we've put together. And we toured all of Norway in August and did talks in Bergen and Oslo and other places, and people really liked it. It was very well received, thankfully, and I've continued that, and I've done more of that here. In fact, Ket and I will be at the UFO MegaCon. I was there last year, and they're having me back, and this time Ket's going to be there, and we're going to do our talk. We're going to do the new science tour talks there, and that's a joint talk where we both are on the stage together and talk about the sciences. Hers is from an astrophysics point of view. Mine is from the astronomy point of view. Remember what I said, okay? Astronomy is what's that in the sky? Astrophysics is how does it work? And cosmology is why is it there? Why does it work? You know, it's kind of how I think of it. This is a cute little nebula that I really like. And when I show you the image this way, it's a little better. Think of this as an eyeball, and think of this as an open mouth here. Okay? And then think of the noise, waka, 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 and what do you think of? Waka, 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 you know?
Well, are we going all the way back to Pac-Man?
Yes, that is Pac-Man. This is the Pac-Man Nebula. Yeah. Yeah. Yeah, this is the Pac-Man Nebula. So I wanted to just acquire it. And now what we can do is we can actually, I'll show you what I'm doing. We're going to go to 25,600. No, we won't. We're going to go to 32,000. And we're going to go 20 seconds. All right. And let's tweak the telescope. As you can see, the telescope is right on the money with its pointing accuracy. I spent some time getting that realigned. Really, 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 really good. So even on both sides of what we call the meridian or the zenith, and even near the pole, it's really pretty accurate now. Very, very pleasurable to look at objects when they are there when you expect them to be.
Yeah. Solid.
Yeah. Well, here is the Pac-Man Nebula again. Let's see if a little processing can show us anything. You can actually see much more of the hydrogen distribution of the gas here. See the convolutions in the dark nebula in there? Yeah. Pac-Man is really quite special. I'm noticing it's got a little brightness to it, and I'm concerned that we're getting some clouds. Evil clouds. I do not want them.
No.
Wait, let me go see. Are there clouds? No, I don't see any clouds. You see clouds? Yeah. And that means it's on the side of... yes, it's on the side of the northern side, which means they've crossed over. They have crossed over to the dark side.
Well, you see how that works.
Yeah, you know what? I gotta show you guys something. I'll be right back. I'll be just 2 seconds. I gotta grab something right here.
All right. Okay. The dark side. So. Do you get trick-or-treaters where you live, Daryl?
Not like I used to, but I still get some. It's one of those things that makes me sad. I used to get so many trick-or-treaters here, and helicopter parents and safe spaces and all that junk nowadays. So I don't get near as many as I used to. They're going to planned events, or whatever they do nowadays. But I still get some.
Yeah.
Well, when I moved into this house,
I always buy way too much candy too.
That's the bad. I always like to buy stuff I don't like at all, and then there's no problem if we don't get trick-or-treaters. Okay, so anyway.
When I moved into this house, the driveway is 160 feet long, so we get no trick-or-treaters. You know why? They do the math. Okay, we're gonna go up this driveway for one little tiny Snickers bar. It ain't worth it, man. Let's go to the next house, and then go to 3 houses. And the time it takes to go up that driveway and down again, we could grab 10 Snickers bars.
Totally. Yeah, see, okay,
Yeah.
just didn't pay off. All right. Yeah.
So we just leave the light off and nobody comes.
Yeah, it's funny.
It's not
we've had
fun. But
fewer and fewer, but yeah, it's a lot of decorations in the yard around here, the various yards. But and we're close to the colleges, so they do their own combined campus stuff. They have a lot of things for little kids. So anyway.
I'm taking a picture of a couple of clusters that are kind of right near each other. Good. There's small, one here, one there. NGC 133 and NGC 146. We shall see. And speaking of that, I tell you, I showed this before. You can't see it on the camera because I don't have the camera up right now. Let me just bring it up. This glass jar I've had for about probably 25 years, and it has a name on it. It's called the Vader bottle. I don't know if you can see it. And it's because every time you talk in it, you become Darth Vader. So when you go to talk in it, you are now part of a rebel alliance and a traitor. Take her away. And now you're Darth Vader. And so
that's wonderful.
The Vader bottle has been here with me throughout all, and I absolutely love my Vader bottle.
That is incredible.
It was a total non sequitur, and I'm sorry. But I just had to do it.
Absolutely wonderful. Yeah, well,
had to do
it's something, yeah. Well, if I ever interview you again, we're going to have to probably, or how about when I do next time, we'll just have to get that out of the way, right at the top of the show. And then if I don't know, you're not very, well, obviously you're not totally private about it, or we wouldn't have just been regaled with it.
No. I've done that. I've actually done it on the air before with people.
Well, then where's the fun? Okay, no big reveal. That's okay.
When I was in college, I actually had my friend had a radio show, Doug Green, majored in film, very good guy, worked on a number of really cool movies, and he would sometimes want to go to dinner, and he'd say, "Could you fill in for me?" And I said, "Yeah, what do you want me to do?" He goes, "Well, just call in and talk to yourself." I knew exactly what he meant. So I used to do 80 different character impressions. And so I would call in, and Popeye would fight it out with Darth Vader. Darth Vader would issue orders, and then Olive Oyl would say, "Hell no." And Mickey Mouse would get in there. Goofy would come in, Pluto. Okay. And then, I had all these characters that I did, and I had a little list. And I would just go through them and just randomly select them. And boom, I see the name, and out comes the voice, Then 4.5 years ago, when I had my surgery that went awry, as part of that surgery consequence, besides 8 strokes and quadriplegia and blindness, I lost my voice and I lost the vocal cord. Everything else I managed to fight back, but that one vocal cord didn't come back. So I have a paralyzed vocal cord. It's still dead. But I have a deep voice now that I'd never had before. I could talk like Lou Rawls. Hey, I'm Lou Rawls. I could never do that before. So there's the silver lining. But I did lose more than half.
So amazing.
I lost more than half of my characters that I used to do. Unfortunately. It's just the way it is, Just the way it is.
Well, it's very interesting because you're not left with any sign of any kind of impairment at all. I mean, it's not, So you're lucky in that regard.
Yeah, I guess.
And then, of course, there's that Lou Rawls thing.
Yes, exactly. I'd say, "You'll never find another love like mine because I'm crazy." I don't know.
There you go.
I don't know. Or is it Barry White? I don't know.
Oh, it could have been Barry White.
Yeah, I don't know.
It could have been. And then there's another guy whose name escapes me at the moment. It's gone. Anyway.
Okay. Hey, Daryl, look, there's another red star. These
what
bright,
is that?
Well, these little red stars.
Yeah.
Are red dwarfs, and they are the most populous star in the entire galaxy. Here's one here. Mm-hmm. Here's one up here. There is this one down here, down here, down here. I mean, in every field, you're going to find tons of them. It's pretty interesting. Pretty interesting.
Are they extra red?
Yeah, they're extra red. Sometimes they're called carbon stars because of the way they dredge up a material on their outer surfaces. And
right.
It happens to be a lot of carbon atoms.
Okay, but I meant specifically, are they more red than you remember observing previously?
No, I mean they're actually
okay. This is their standard. Okay.
Yes, this is yeah, but they're very small stars. Sometimes 1/100th the luminosity of the sun, so they're really, really tiny. In fact, when we talk about these stars, we know that most of these stars have planets around them. So they have more planets around them than any other type of star. The problem is that these stars also give off a lot of ultraviolet flares. So life would be challenged to survive there in some of the history of the star. When it calmed down, then life could exist there. But on the other hand, because these stars are so small, that means that their planets are closer. And it means that the habitable zone around the star, where it's not too hot, not too cold, where liquid water could be, would be in a place where the planet had to be so close that it's tidally locked to the star, meaning that the same face faces it, just like with the moon. And so you'd have on those planets, you'd have life forms that just have one side that's sunlight all day long, the edge, it's always sunset, and the backside, which is always dark. And could life arise in those different biomes? I think so. On the sunlit side, it would be challenged with the flares, but on the edge, on the sunset side, ring around the outside edge, and on the backside, not so much. The sunset side might, if they never traveled to the sunlit side, might never knew there was a sun. Because the planet doesn't rotate. It's locked to the star. And what kind of beings would develop there? Well, maybe we're talking about creatures like the Greys we see, where vision is most important in the dark. And so in the dark, on those planets, maybe they develop very, very large eyes. And thus we see the Greys with these very, very large eyes and pasty gray skin. Well, that pasty gray skin could be ultraviolet protection or insulation. It could also be a spacesuit, but if they need such a thing for our atmosphere. But I think it's all fascinating to talk about, and if you think about it, when we have, for instance, on our in our minds, when we try to think about life forms elsewhere, one of the things, and we're looking at this panoply of stars here, certainly with the red stars we see in here, we know that there's probably potentially life on some of these stars we're looking at right here in our very view, and this view, it's a very tiny piece of the night sky, and maybe we're looking at life right here, and if the evolution on the planets around one of these stars was such that they never had extinction events on their planet like we did. We had 5 major extinction level events. 252 million years ago, we had the Permian extinction, and that wiped out 98% of all the life here. And yet life persisted. Interestingly enough, at that point, it was the pre-mammals, the things that would become mammals, that were dominant. And they got hardest hit by that extinction event. And they retreated into the shadows, and that gave rise to reptiles. And thus the age of the reptiles began. And that was stopped only because of another extinction event 65 million years ago. The used to be called the KT Boundary. It's the Cretaceous Paleogene event now, they call it. It was the asteroid that killed the dinosaurs. And when that asteroid struck here, the dinosaurs were hardest hit, and the things that would become mammals were not. It was the exact opposite situation from the Permian era, where mammals had to retreat because they were hardest hit. Reptiles arose, and thus from the Permian to the Jurassic, we had the age of the reptiles. That's why we had reptiles on this planet, because of extinction events leading them to the forefront for a little while. So far, they're the most successful, group of species on a whole of any other species in the world. When the Cretaceous Paleogene event occurred 65 million years ago, and they were wiped out, all those niches were empty now that dinosaurs and reptiles had occupied. And the mammals were waiting in the wings going, "Hey, Frank, let's go. It's open. Look." And off they went. And they started to populate these niches. And now, I think it's really important to understand that if evolution occurs elsewhere, as we know it must, that's sort of facetious, then it's probably likely that it didn't happen in the same exact metered way that it happened here. We are the way we are exactly because of the events that transpired here prior to Homo sapiens sapiens. Okay? And prior to Australopithecus afarensis, Lucy. Okay, those events prior to that shaped what was to come. And on a distant world, if there was a species of reptile that arose through some type of extinction or just by the nature of the dominance, then who's to say that it might not have reached some type of intelligence at some point? Intelligence isn't a foregone conclusion. It's just a potential journey down the path. So maybe they would have reached some intelligence. And of all these stars we're seeing here, if there was some that did reach that intelligence level that was higher, then perhaps they would be, as Zark says, so advanced that they could have gone interstellar long before us. I mean, we're only 4.6 billion years old in a universe that may be 13.8 billion years old. I say maybe because the expansion rate of the universe calls into question the age. Might be 12.6 billion years old now. But anyway, bottom line is, if they didn't have the same types of extinction events, but reptiles still arose on their planet, then we could have a species of reptiles that were intelligent. Reptilians, as people will call them. It really, scientifically, can't be taken off the table. It certainly isn't something we can prove, and it's really nothing that we can even suspect. We can't even see how reptiles could make it to some type of intelligence. The cranial development is kind of, the most important thing there. However, during the Jurassic and at the extinction level event from 65 million years ago, there was one particular meat eater, a theropod it's called, that was actually increasing its cranial capacity and getting smarter at the time that it was killed off by the asteroid. So does that mean it would have made it to intelligence? We don't know. Isn't that cool?
There's a precedent. I did not know that.
Yeah.
Whoa.
So
that is most intriguing.
Yeah, now Daisy in the chat, Daisy and Zoe Amethyst, Daisy asks, what is waiting to replace us? Right? What's hiding in the wings? What do you think, Daryl?
I don't know.
Okay.
Dolphins.
Actually, see,
bonobos, whatever they call them. Dolphins. I like dolphins.
Me too. Dolphins are pretty smart. Pretty smart. Their brains are a little bigger than ours.
And hey, so long and thanks for all the fish,
I thought
Douglas Adams, of course.
Yes, Hitchhiker's Guide. I thought it was really good.
Right.
Really, really good. Yeah. I kind of even like the remake.
I'm sorry, Mark, Carol, would you all excuse me, please? I'm going to call it a night here.
All right, Daryl. We'll have you on.
Thank you for having me on.
Yeah, we're going to be...
Carol, it's been a pleasure. It's nice meeting you. Hopefully we get to talk again soon.
Hey, very nice to meet you on the air like this. This was really neat. Enjoy the rest of your evening.
So thank you. You all take care and have fun. Good night, everybody.
All right, Daryl. We'll see you later.
Okay, bye-bye.
Bye. Yeah, I don't know. I mean, I liked Hitchhiker's Guide to the Galaxy. The book was good. The concept of the babblefish, yeah, that's right. Zark, babblefish around the ear. And I really kind of like the concept of just blowing away the Earth to make way for a new highway or something like that. That was really just kind of funny. because it was as if humans were just of no consequence.
Right. All of our achievements, all of our so-called accomplishments. Yeah. Just who needs it? Yeah, exactly.
Yeah. But
Yeah.
so what I'm going to do, I mean, we are actually we're getting clouds that are coming in now, so we're not going to be able to go much further, unfortunately. So I'm afraid that we're going to end up calling it tonight. I am surprised we got this far, guys, to be honest. We did 2 hours and 30 minutes here, and I'm really happy that we got this far tonight because it didn't appear like we would.
Wow. Doesn't
Yeah.
seem like that much time has elapsed. So,
I know.
yeah. So, and you think the clouds are making it curtains, so to speak.
They are actually.
Yeah.
I can see when I look at my other cameras here. I got those clouds have now crested over the observatory and they're moving into the northern sky. But I do want to say hi to D Smith and Gas Mask. I didn't say hi to you before. Sorry. Nice to see you guys here. You've probably been here for a while. And I was saying Gas Mask has a question, or not a question, a statement. I think it was Nat Geo did a show. They speculate that we would modify some of the genes for space travel, and those humans would look like something like okay. If we modified ourselves for space travel, well, that's if we did conventional space travel, I think. If we live in the string theory world, then we may not have to actually carry out high G turns and long-term travel. It might be far easier than that. We can punch out and punch in. And so a trip to a distant galaxy, or not galaxy, say, but another star in the galaxy that's, say, 20,000 light years away, might only take as long as it takes to go from, Connecticut to Maine, maybe a 4-hour trip, 5-hour trip. So that's possible. So I think that is something that may come down the pike in the future for us. We already see ways to beat the light speed limit imposed by the universe in regular space. That's right, Zark. The Alcubierre drive, he says, folding space. That's right. In 1994, Miguel Alcubierre came up with this tensor, a mathematical project, which basically showed that you could fold space, create a warp bubble around your ship, and basically compress the distance from you to your destination and lengthen the distance between you and your origin, so you could kind of get there. And rather than a pencil through paper, Zark, that kind of starts to imply wormhole. Think of folding up the paper and touching the opposite corners together. If you traveled from corner to corner unfolded, that takes a long time, but going corner to corner if you fold space is a lot quicker. That's an analogy that you can use for the Alcubierre drive that I think works better. And so the initial Alcubierre power requirement needed to be really, really high. And it was so high, in fact, that it required the planet Jupiter's mass converted to energy to generate this warp bubble. And that was really just stupendously impossible, even probably for an advanced civilization. So they, Miguel Alcubierre put it on the shelf and said, "Wow, Miguel, that's pretty cool, but it's impractical." "Yeah, I know, it's just a thought problem." Well, Sonny White, a scientist from Eagle Labs, which is a NASA-funded lab, took another look at the Alcubierre mathematics and realized that it was sort of incomplete, and he made some changes to it. And the changes that he made to it were that he altered the way the warp bubble is generated by the ship. And that warp bubble needed a certain amount of power to be generated. Well, he altered the geometry of the bubble, or the ship's is a toroidal ring that generates this warp bubble. He altered that and found that he could reduce the energy requirement by something like 10 to the 26th or 10 to the 27th power. I mean, that's a huge difference there. But and that meant that now we're talking not about having to convert a mass the size of Jupiter into energy to get the warp bubble, but a mass the size of, say, 2 Volkswagen Beetles to get the energy to make the warp bubble. And now that, still impractical for us, made it distantly plausible. And so NASA funded the EagleWorks labs to actually look into the Alcubierre drive, actually a variation of it, called the Froning Alcubierre drive. Froning, I believe, was a mathematician who worked out that when the Alcubierre drive is moving through space, one of the consequences that Miguel Alcubierre came up with and found was that energy would build up on the front of that bubble as you're going across the gap. And that energy was extremely hazardous. It's like bugs on a windshield, if you can imagine. When you stop your car, if all the bugs came off and splattered on whoever was the closest, but with the force of the car's motion, you could imagine it would riddle them like with holes like bullets. Well, that problem that problem was solved by Froning. He managed to figure out a way to shunt the bugs around the ship, effectively making what is like Star Trek shields.
Yeah.
You know, which is kind of cool. And the Star Trek shields were what people called them, and it was an apt analogy. And so the Froning Alcubierre drive eliminates the problem to some extent, to a great extent, of unleashing absolutely holy hell on the solar system you're now arriving at, where you literally could produce a focused beam of energy when you stopped that could obliterate the very planet you're coming to see. That would be kind of bad, you know.
Yeah.
As you start to come out of your Alcubierre warp and you see this planet with, wow, look at that, they got stations and people and everything, and you stop your ship, the bugs come off the windshield, blow the entire solar system to kingdom come, and now all you hear is crickets in your ship, you know. You're like, hey, Frank, let's just tell him we didn't see anything. Yeah, right, good idea. Yeah, and nothing to see here.
Yeah, transporter psychosis.
Quickly out of the way. Yeah. So anyway, that was that's sort of the that's the thing that you can turn the Alcubierre drive into a weapon too. So clearly, you know, we have to be careful. You know, so the Froning drive variation will be safer. But
I think safer is definitely a good thing when it comes to blowing stuff up. I think it's
agreed. But anyway, folks, I want to thank you guys for watching tonight. I really enjoyed your company, as did Daryl and Carol, and we are looking forward to having you back again to watch more. I really want to show you more stuff. As the winter approaches, we will be able to check out Orion. I cannot wait to start imaging the Horsehead Nebula with this filter and telescope setup. In previous years, it was always very dim, and I think this will be a banner year for looking at these nebulae. But thank you guys for coming on board, and I look forward to seeing you again here on SkyTour LiveStream. I am Mark D'Antonio, and Carol Carl was our special guest tonight, along with Daryl Mason as usual. And I will see you guys the next stream, which could be as soon as tomorrow if it's clear. So we'll see you later, guys, and good night to all of you. Thank you very much for coming.